All right, well, welcome. I think we'd like to get going. We have 3 presentations to get through in the first hour. We're thrilled to be able to give these presentations. This is a culmination of a lot of work for a lot of students, faculty too, and staff too, and especially liaisons. We really appreciate the sponsoring organizations for all of these projects. We couldn't do it without them. So let's give a hand right now to those who have put a lot of work into this. Okay, so as I say, these projects, I think many of you know how the projects work. Students work on these projects over the course of the entire year. In the fall, they put together presentations that outline the work that they're going to do. They do much of that work in the winter and spring, and now we're finally at the end. And they do have reports. I think almost all of them are in. So with no further ado, I'd like to introduce the first team. So the first project is sponsored by Snoqualmie Valley Preservation Alliance. By Skagit County, Skagit Fisheries. I'm getting ahead of myself. This is CEE Team 23.4. And you can come up and introduce yourself.
All right. Thank you, Dr. Lauer, and thank you everybody for being here. We are Seattle U Civil and Environmental Engineering Team 23.4, and we have been working diligently over the past 9 months on this Cascade Trail of rehabilitation. We've been working with Skagit County Parks and Rec and Skagit Fisheries Enhancement Group. And so first off, I'm going to go over an outline of our presentation. We're going to go over the project background. Then we'll be talking about the proposed alternatives. The one we did an alternatives analysis, and then using that, we selected an alternative, found a final design, and then our conclusions will wrap it up. So this is our management structure. So from Skagit Fisheries, we have Allison Studley, who is our liaison, and from Skagit County, we have Brian Adams, Joseph Shea, and Emily Doreen, who will help us with the project. And on the Seattle U side, we have Dr. Zong and Dr. Lauer, who are our faculty advisors, and then Dr. Lauer, who is also our project coordinator. And for our team, we have Ryan McGeary, Megan Martindale, Jamie Kaufman, and me, Alex Robles. So this is our site overview. So as you can see, it's in near Cedro-Woolley, Washington, which is about an hour and a half north of here. And our project site is a 1,900-foot stretch of trail on the Cascade Trail. And Wiseman Creek, as you can see, runs through the Cascade Trail. And I'll talk more about that in the problem statement. And it's right by State Route 20 and properties on either side. So these are our project objectives. So we analyze literature and data to understand the problem. Then using that literature and data, we determined 4 final design solutions. We used an evaluation matrix to determine the best solution out of those 4, and then delivered 10% design drawings and a final report to our liaisons and Seattle University. So this is our project roadmap. First, we had to understand the problem. Then we did a literature review and survey of the area. And in the literature review, we mainly focused on a 2006 feasibility study that went over our project site and talked about very similar things to what we were looking at. After that, we determined 4 potential solutions and created an evaluation matrix to find which one was the best. After we selected our preferred alternative, we made 10% design drawings of it and created a final report and deliverables for Skagit County and Seattle U. So this is our statement of problem. So as you can see on the right, the trail is completely inundated with flow from Wiseman Creek. And when this happens, the trail is very inaccessible, and trail users either have to detour along State Route 20, which is a freeway, not too safe to walk along. They either have to turn back, which they complain about to Skagit County, or they continue through the flooded trail, which isn't preferred for the fish or for the trail. And as you can see, the trail users cause disruptions to the salmon habitat during the flooding, and we've seen diminishing salmon returns since the 1990s from data that was provided to us. And the sediment deposition that the Wiseman Creek has, it's very sediment heavy and deposits sediment across the Cascade Trail very frequently. And that makes it very difficult to walk along and channel it, and is just not good in general.
All right, so I want to give you guys kind of an overview of the topography in the area and what's causing the problems. So here's a relative elevation map with the higher elevations in white, lower elevations in green. And Wiseman Creek comes out of the hills there, crosses State Route 20 and crosses Minkler Road, and is fairly constrained through that whole region. As it enters this lower, lighter green band close to the Cascade Trail, it is free to spread out, it slows down, and that causes it to lose a lot of sediment. As it drops the sediment, it tends to fill up one channel over time and move into a new channel. This causes the kind of fan shape that you can see at the bottom, and it causes the flow to change locations very frequently. One piece of analysis that we did to determine the magnitude of this change was elevation differencing over time. So we had two data sets, one from 2017 and one from 2022, that had elevations of our trail region. We took the difference in elevation between these, which is shown with erosion in red and sediment deposition in green on this map. The magnitude of this had a maximum extent of about +2 feet in either direction, erosion and deposition, and a histogram of the change in elevation is shown at the bottom. So most of that change is within kind of ±1 foot, but the maximum extent is up to 2 feet in either direction, which informs us of the kind of size of solution that we have to implement. So here's a video that shows kind of the trail during one of our site visits. There's a small bridge on the right-hand side there, which was implemented about 20 years ago over one particular channel. And as you can see, that small bridge is no longer an effective solution. So here's from two of our site visits, one in November and one in January. This is the same location on the trail. In November, there's one fairly clearly defined channel that Wiseman Creek is using to cut across the trail. When we came back in January, that specific channel had almost entirely filled up with sediment and the flow had moved elsewhere. So this just kind of goes to show how dynamic the landscape is in the region and how the smaller solutions like single bridges over a single channel are not effective over time. And this is an example of that. So this bridge was installed in the mid-2000s. And at the time, it was an effective solution to cross this channel of Wiseman Creek. Now, when we came back in January 2023, that's that same bridge, and it's no longer providing access down the trail corridor. So we came up with 4 proposed alternatives that could solve the problem. The first was no new action, just continuing as it is. The second is rerouting the trail. The third is raising the trail. And the last is a full boardwalk over the extent of the affected area. So for the first alternative, we wanted to analyze the current state of the trail in order to compare our other alternatives to it. So this involves leaving the trail as it is, doing the maintenance that Skagit County currently does every summer, which involves regrading almost that entire section of trail. And trail users are detoured onto State Route 20 if they want to go around the trail. The habitat disruption from Wiseman Creek being channelized along the trail and from trail users moving through the sediment would continue to exist under this circumstance. The second option we looked at was rerouting the entire trail to avoid the affected area. And this would involve going up onto Minkler Road and then either coming across on Highway 20 before cutting back to the trail or staying above the wetland area, but not on Highway 20 and coming back to the trail. This would require acquiring land or the ability to put a trail through there. And that was deemed difficult. The other option we looked at was raising the trail. Now this would involve bringing in soil to fill the area and bring the trail's elevation above both the sediment deposition over time and floodwaters, and creating certain channels with bridges over them that the creek could move through. There are issues that come up with channelizing the creek, and that's one of the problems that the salmon habitat is facing currently. So this solution doesn't necessarily solve all of the habitat problems. And then the last alternative we looked at was building a boardwalk along the entire 1,900-foot affected section. And this is what's shown in this drawing. The creek is able to move along the length of the boardwalk. And so it effectively separates the trail and the creek system.
Great. So now that we've talked about all of our different design alternatives, it's time to evaluate them. And we did this by using an evaluation matrix that has 6 different criteria on a score from 1 to 5, with 1 being a low score and 5 being a high score. So now we'll talk about some of those criteria. Constructability is our first criteria. Here we really want to make sure that whichever design alternative we select is easy to construct and doesn't require excessive land acquisition, any excessive heavy machinery, or extra support from exterior contractors. Next up, we look at recreation and Zoom notification. Sorry about that. Next up, we look at recreation, and here we want to make sure that the trail is accessible to all of our trail users, which include pedestrians, cyclists, and equestrian users. And we want to make sure that these trail users have access all year round. Next up, we're looking at environment. And here we want to make sure that we're restoring the Wiseman Creek alluvial fan region to its natural hydrologic functions. So one of the ways we can do this is by separating the trail and the wetland habitat. Next up is longevity. And here we're looking at any expected future maintenance costs and also the expected lifespan of any of our designs. Then we have permittability, and this refers to the ease of obtaining permitting from any local, state, or federal government agencies. And finally, we have upfront cost, and this criteria refers to the initial investment required to actually build our design alternative. So we used all those different criteria and we analyzed each of our alternatives, and we came up with these results here shown on the screen. You can see that the full length boardwalk has the highest score. So this is what we selected as our final design alternative to bring to a 10% design. You'll also notice here that we have our scoring criteria weightings on the bottom, and this is really to show that the focus of our project is on recreation and environment. And although all of these criteria are important, since our focus is recreation and environment, those have a higher weighting of 25%. So now that we've talked about some of our criteria, let's look at our design components. On the board here, you'll see the full length boardwalk, which we plan to be 6 feet wide, 1,900 feet long, and to have about a 30-year lifespan. In this plan view here, we considered a couple of design constraints, one of those being existing bridges that exist on both west and east ends of our proposed boardwalk. So to address this concern, we proposed that the boardwalk widens to meet the existing bridge. Another concern we had is 2 equestrian users passing each other on our 6-foot wide boardwalk. We're not quite sure if they'll be able to squeeze past each other. So to address this, we had pullouts at 1/3 and 2/3 of the length of the boardwalk. That way equestrian users can pull off to the side and let each other pass safely. Next up, we'll look at a profile view. So in the above profile, you can see that we look to maintain about 4 feet above the average grade. And we also look to be 4 feet below grade. And these 4 feet above and below numbers come from the LiDAR differencing that we discussed earlier in the presentation. You'll also notice here that we have a maximum 2% slope. And this slope is ADA compliant, and it also matches the existing grade of the Cascade Trail. You'll also see that we have a 10-foot typical span between our supports. And when we zoom into those supports and look at this cross section, you'll notice that we have 3.5-foot tall handrails for pedestrian safety. And we plan to use 3x8 composite decking that's rated for equestrian use and also has tractioning over the top. The roughening surface or traction is to prevent slipping during the wet season. And the rating for equestrian users just means that any equestrian users walking along the boardwalk don't have to worry about their horse's hooves punching through the deck. So that's important for safety as well. You'll also see that we call it a 2% cross slope, and this is to help Skagit County Parks and Rec with any of their maintenance. So now that we've talked about some of our design components, I'll pass it off to Ryan, who'll talk about benefits.
So as we've recapped our design here, we look at the overall benefits for the environment. We looked at it mitigated the human impact on the salmon habitat, and it also allows the alluvial fan to function naturally. For recreational use, this provides year-round access throughout the trail corridor for pedestrians, cyclists, and equestrian users, and it prevents users from needing to detour around to Highway 20, which is a safety concern. Additionally, this solves a long-standing issue within Skagit County. The feasibility study we talked about earlier was conducted in 2006, and there was no preceding action. So this has just been a lingering problem that we were hoping to solve here. So now to look at how much this thing costs, we looked at 32 observations of other wetland design boardwalks. We then found an average cost of 710 pounds per lineal foot, which we applied to the full length of our boardwalk, which gives us this cost of $1.4 million. After applying a 30% contingency, we then see a estimate of $1.8 million. As for maintenance cost, the current trail conditions that Skagit County is doing is requiring about $9,700 per year on average to just brush the trail and regrade it, which they do every year. With the addition of the boardwalk, this then changes to $11,000. However, there is no more need for the trail to be regraded as people are just walking over the top of the wetland. Our 30-year present values are shown here. So before maintenance, we are looking at $275,000. And then afterwards, this increases to $323,000. Now, these numbers do not reflect the qualitative benefits that we do get from having the boardwalk, which are the recreational benefits of having year-round accessibility along the trail corridor, as well as improving the safety by avoiding the State Route 20 detour. And finally, ideally restoring the salmon spawning habitat along Wiseman Creek. So for further development, we have delivered this to Skagit County to aid in the acquisition of grants and other funding to accompany the cost of the boardwalk. We then had discussions with their liaisons about working with potential partners such as Washington Trails Association, Skagit Trail Builders, and Skagit Whatcom Island Trail Maintenance Organization to help reduce the cost. And furthermore, we looked at potentially making this trail an adopted trail, which would also help to alleviate some of the additional maintenance cost. And that is all we have. Are there any questions? Yeah, so a lot of those boardwalk estimates that we looked at, most of these were in the Pacific Northwest. We looked at about 16 of those actually came from Caltrans, which is the California Department of Transportation. One of these was in a wetland over in Florida. So we looked at all of these and then adjusted those costs based on the inflation rate. And there were some minor regional adjustments that we had to make as well. But most were in the Pacific Northwest.
So we had a lot of really extensive conversations with our faculty advisors and our liaisons about how we wanted to weight each of the different aspects of our project. When we ran through the evaluation matrix at first and kind of proposed our idea, there was a lot of discussion about how different criteria needed to be weighted differently to really reflect the purpose of the project. So those numbers came from an extensive survey that we did between our advisors and liaisons. And we kind of took the numbers from how our liaisons thought how important each criteria was. And we did a lot of weighting and Excel work to come up with those final numbers. Yeah.
The 4-foot difference that I saw was based on like study between 2006 and now, or did you consider 100-year flood or
Yeah, so we didn't have enough flow data in Wiseman Creek to come up with flood elevations. And there weren't any like FEMA flood maps that were recent enough to give us an accurate representation of flood elevations. So that 4-foot number came from considering the sediment deposition and erosion, as well as adding multiple feet on top to consider the floodwaters.
So the trail has a 30-year lifespan. I can't think of any risks. Everything's ADA accessible, safe for horses. We did load calculations to make sure that the trail would support everything as well.
All right. Okay, so this is team 23.6. One thing to say about team 23.6 is that they entered their presentation in a National American Society of Civil Engineers Congress. They call it a Congress, the Environmental Water Resources Institute Congress. It's a conference, and it was in Las Vegas a couple weeks ago. Well, actually last week, and they won first place for this presentation. So great job, team. And with that, I'll let you get going.
Can you guys hear me okay? Okay, cool. Without further ado, we are Team CE 23.6, and this is our project on the Snoqualmie River gauge screening algorithm and inundation map development. Outline for this project will consist of the background, our study objectives, methods, results, conclusions, future work, and some room for questions at the end. Snoqualmie Valley Preservation Alliance, or SVPA, were our sponsors for this project with Gary Epley, Regina Fletcher, and Lauren Silver. Seattle University faculty includes Dr. Sayun Lee as our faculty advisor and Dr. Wes Lauer as the project coordinator. And we are the student team.
I'm Ruby.
I'm Jamie.
And I'm Owen.
So going into the background for our study site, we were primarily working within the Snoqualmie River Valley, which lies 40 minutes east of Seattle. It is also to the west of the Cascade mountain range, which is important when you take into account the frequent flooding that occurs in the area, as during the rainy season and the snowmelt seasons, all that excess water comes trickling down the mountains into the valley basin, producing these frequent floods that flood the farmlands, which impacts the livelihoods of not only the farmers, but also the residents of the valley alike, who so rely on our sponsors to provide them with good, accurate flood information, which Ruby will now explain how they do.
So to provide flood monitoring to the Snoqualmie community, in 2019, SVPA developed the Floodzilla website. Floodzilla provides real-time flooding information to users using a network of gauges along the river, as shown in this screenshot of the website. If a user is to click on one of these gauges, it would bring them to a page that provides information such as water level and water flow. Scrolling down on that page, users can also view the flooding status. So whether or not that gauge is currently normal, near flooding, or flooding. While this is really useful information for users, it does have its limitations, as flooding information is only available at gauge locations, meaning that users who do not live right next to a gauge may have a difficult time discerning how a flooding event is going to affect their property and their livelihood.
Thank you, Ruby. And SVPA uploads water level and flow rate data from 7 gauges, which are owned by the United States Geological Survey, or USGS. In addition to that, SVPA also owns and operates a series of 10 active gauges, which utilize ultrasonic technology to record water level in the valley. Currently, SVPA has a preliminary screening algorithm, which will flag and remove data points when the water level is recorded to change at a rate above 2 feet per hour. SVPA defined this parameter based off their observations that water level readings recorded at their gauges typically do not exceed this rate. Although this screening algorithm has helped SVPA to flag data, it does not adequately capture erroneous readings caused by an obstruction between the gauge sensor and the ground surface, such as a tree log, spider webs, or Seattle University students on site, as you can see pictured. Furthermore, there is evidence of valid water level readings which change at a rate above 2 feet per hour, such as when a flood crests and flows quickly into a drainage ditch, which is often the case for our SVPA 15 gauge.
This is a graph of data read from SVPA gauges placed along Snoqualmie River and uploaded to their website. On the y-axis, we have stage, and on the x-axis, we have time. The red X's represent all the data points the SVPA was flagged automatically using their parameter that Jamie mentioned earlier of anything greater than a rate of change of 2 feet per hour. All the green pluses represent all the data points the SVPA had to go in and manually flag and remove themselves, which speaks to the amount of effort and manual labor that goes into maintaining the quality of data that is posted to their website. For our project, we had 2 study objectives, the first of which was to design an automated screening algorithm to help minimize the manual removal of erroneous data, and the second of which was to develop a way to visualize the extent of flooding events to residents in the Snoqualmie Valley by creating inundation or flooding maps as shown in this example here. Now we will go into some of our methods. For the screening algorithm, we implemented 3 parameters from USGS, first of which being range, or checking whether or not a given data point falls within the natural boundary for a gauge. Second of which being rate of change with minimum and maximum values. And third being consistency checks with adjacent gauge readings. Sean will now go into a bit more detail in the coming slides about how this all works.
So as Owen mentioned earlier, we will be implementing USGS's 3 methods of screening their data onto our sponsors gauges as well. Here we have a rough outline of the flow chart that our algorithm will seek to take, and we will be explaining the particulars of it in the slides to come. Here we have the 3 basic parameters that we will be implementing, starting with a check for minimum and maximum water elevation checks for the gauge's historical readings. When a point passes through that parameter, it is then checked to see if it lies within the minimum and maximum rate of changes that we've established at each gauge. If it passes that as well, then we will compare it to an upstream USGS gauge to make sure that our sponsor's gauge readings make sense in the context of the whole river. And now we'll go into the particulars of our minimum and maximum stage boundaries. For our minimum stage elevations, we simply went ahead and within our 2-year study period, picked out the lowest published point available for all 6 of the gauges we were studying, as tabulated here on the right. For our maximum, we did much the same. We just looked at the highest published point available to us in our study period and tabulated that as our soft maximum limit for our gauges. When a point succeeds in passing through that parameter, we then go into the minimum and maximum rate of change checks. For our maximum rate of change, we have decided to keep our sponsor's existing 2 feet per hour parameter as our maximum, as it is historically proven to capture erroneous data without capturing too much publishable data as well. For our minimum rate of change, we will be selecting to look at data points that represent a rate of change of 0 feet per hour from the previous point. As you can see here, this is a zoomed in plot of SVPA gauge number 25 with our sponsors manually flagged data in the red X's. There's this very discerning trend here where a lot of these points like to be right next to each other. So if we're looking to make an algorithm that can kind of exploit this behavior to reduce the workload on this gauge by roughly 50%.
And our final parameter will consist of a comparison between USGS gauge readings and SVPA gauge readings. The goal of this parameter is to verify that incoming stage readings at SVPA gauges are consistent with those of an upstream USGS gauge. Our screening algorithm will require that any data that was flagged by the previous parameters Sean discussed undergo a consistency check before they are permanently flagged and removed. Up on the screen, you can see 2 stage hydrographs, one for SVPA 26 and one for USGS 38. Note that USGS 38 is upstream of SVPA 26, meaning that when a flood flows through the river, it will peak at USGS 38 before it is recorded at SVPA 26. Therefore, to effectively compare the 2 gauge readings, we had to determine the average time lag between when a max stage is recorded at both gauges, as well, which we denote as delta T, as well as the average height difference between peak stages at both gauges, which we denote as delta H, which is due to the difference in datums that the gauges have. We calculated delta H and delta T values based on a variety of flood magnitudes to ensure we had representative parameters of multiple flooding events. After which, we shifted up our USGS gauge based off the delta H and delta T parameters to create what we like to call an SVPA predicted value. Now, all incoming stage data will be compared to this SVPA predicted value.
So going into the methods for our inundation map development, we'll be using ArcGIS to compile a heckgrass water surface elevation map and subtracting from that a LiDAR ground surface elevation map so that we can make a more defined river depth map for any given flood event. Ruby will now go ahead and explain how we went using heckgrass in this project.
Thank you. So as Sean stated, we used HECRAS, which stands for the Hydrologic Engineering Center's River Analysis System. HECRAS allows users to HEC-RAS allows users to model flow throughout a river and outputs a water elevation surface. We utilized a 1D HEC-RAS model of the Snoqualmie River that was developed in 2004 to simulate various flooding events. In this figure here, those green lines there represent cross-sections that come directly from the model. 21 of those cross-sections correspond to boundary conditions, as highlighted in red. Each of these boundary conditions requires an input hydrograph, either an inflow hydrograph, as shown here, which shows flow data from USGS in respect to time, or alternatively, a stage hydrograph, which shows stage data in respect to time. Now, when the model was originally created for these 21 boundary conditions shown here, the necessary stage and inflow hydrographs were determined using data from these 7 USGS gauges. However, since 2004, 2 of these gauges have gone offline. So in order to rectify that, we've gone ahead and added an additional gauge, the USGS 22 Carnation gauge. So now when we run the model for these 21 cross-sections shown here, the necessary stage and inflow hydrographs are created using data from these 6 USGS gauges.
The floods that we modeled in HEC-RAS have been used to create inundation maps or flooding maps. And those flooding maps have been compiled into an inundation map library. We reference these maps to the flow recorded at the USGS Carnation gauge. We chose this gauge because it is midpoint between the upstream and downstream boundaries of the Snoqualmie River and has historically experienced the highest inflows. Many of the floods that we modeled have been based off historical and frequency analysis, based off the annual peak flooding events that have occurred at the USGS Carnation gauge. We use that frequency analysis to create 1 through 100-year return flooding events. We have also modeled in HEC-RAS historically large flooding events that have occurred in the valley, which SVPA has uploaded onto their Floodzilla website.
Now we will go into our results. For the screening algorithm, we performed a correlation analysis on the SVPA and SVPA predicted hydrographs. We found a very strong relationship, especially above the minimum stage values. Now we performed this for each gauge, and we can use this to prove how we're able to check consistency against adjacent gauge readings using this relationship.
So here we have our good friend SVPA gauge 25 again. In the red X's, we have our sponsors, both manual and automatically flagged data. Now, on the next slide, we see our green circles here indicate flagging that we have produced using the new parameters that we've implemented. We've also gone ahead and implemented a new warning system that will provide a warning to anything that is below that minimum established elevation that we have stated in our previous slides. This makes up roughly 40% of SVPA 25's flagging efforts. So we are happy to be able to provide that much reduction in our sponsors' workload.
We'll now go into our results for inundation mapping. We have an animation here that shows some of the various flooding events that we have modeled and created maps for. These are the types of maps that we will provide to SVPA to be displayed on the Floodzilla website that will allow users to see both flood depth and extent.
And to verify that the results of our modeling are reflective of what is occurring in the Snoqualmie Valley, we have plotted the water surface elevation outputted from HEC-RAS along with the water surface elevation recorded at SVPA gauges. Up on the screen, you can see that correlation for a January 22 flood, and that strong correlation has been the case for all of our modeled floods thus far.
In conclusion, we have improved the automated screening algorithm for SVPA by implementing 3 additional parameters, including historical minimum and maximum values, minimum and maximum rates of change, and consistency checks with adjacent USGS gauge readings. In addition to this, we have also provided a way to visualize flooding events to residents in the Snoqualmie Valley through the creation of inundation maps, which display the extent of flooding events. And we have developed a script to make it easy for SVPA to implement this in an automated process.
And now moving into future work, in 2017, King County adopted the 1D HEC-RAS model that we use throughout this project. In the spring and summer months of 2023, King County is working on developing a new 2D HEC-RAS model of the Snoqualmie River. This new model would include updated topographic surveys and hydraulic analysis. We bring this up as we think it's important to know that the methodology that we have developed throughout this project can still be applied to this new 2D model. This would allow SVPA to create new and updated flooding maps to be displayed on the Floodzilla site. Sweet. Thank you, and now I think we have some time for some questions.
conversation. One question I had was on the flooding mitigation map. Was I understanding that you took a gauge kind of in the middle of the valley and applied that to the HEC-RAS model from downstream to the upstream end? In other words, does that consider the floodways, the rising land falling land?
No, that's a good question. I'm happy to clarify that. So the flooding events are based off multiple USGS gauges. I've just noted that that Carnation gauge is the identifier we use to pull a map. So on the Floodzilla website, potentially, all the maps that we have created, if there is a particular flooding event that matches with the flood that was recorded during that flooding event at the USGS Carnation gauge that aligns with what is recorded in the valley currently, then that's the map that they would pull. But all the maps are based off the hydraulic analysis of 6 USGS gauges along the river.
So the mapping for the you're doing the 6 gauges at one time to produce the map.
Yes, yep.
I can try to approach that. Yeah. So the HEC-RAS model we were using is pre-existing and, oh, sorry. It sounded like you were asking about like the feasibility of extending this method and this practice to sort of other regions, not only in the United States, but globally. So for us, the main components that we used in generating these maps in particular was an already existing HEC-RAS model. So it would be pretty reasonable to say that as long as there's some kind of hydraulic model that can be put into HEC-RAS, that this method could be followed to produce similar results. Does that sort of answer the question? Okay.
Thank you, team. Great job. All right, so it'll take a minute to switch, but we'll.
I'm clicking for you, right? Okay. Oh. Oh, there's some chats as well. I don't know if there's a question. Some chats. Hello, everybody. Thank you for coming. We are Team CEE 23.5, and we'll be presenting our pedestrian improvement plan for 52nd Avenue West in coordination with Snohomish County Public Works. Oh, the clicker is not working. Okay, So here's an outline for our presentation today. We'll first be going over our project management structure, the location of our project, as well as our project objectives, our design constraints. Then we'll go into our design alternatives, our decision matrix, our preferred selected alternative, and we'll have a Q&A session at the end. Our sponsors from Snohomish County Public Works are David Lee, Polly Brooks, and Marina Kushnarenko. Our project coordinator is Dr. Wes Lauer, and our faculty advisor is Dr. Ahmed Degenkolb. Finally, on the project engineering team consists of myself, Janice Lee, Glory Chua, John Coleman, and Nizar Nazarchuk. Our project is located in unincorporated Snohomish County on 52nd Avenue West. Here's a picture of our project site, which spans about 600 feet between 164th Street Southwest at the north end and Linwood City limits at the south. This roadway leads access to amenities and buildings, including Meadowdale Townhomes, St. Timothy Lutheran Church, which is also a preschool, Sunquist Family Nature Park, and Beverly Elementary School. And at the south end of our road, it features an earthen dam as well as a regional detention pond. So this part of road is actually built on top of a berm. Right under the road, there's also Lunds Gulch Creek, which flows through a culvert in this section of road. Our project objective was to provide Snohomish County with a preliminary pedestrian improvement plan for 52nd Avenue West to address the lack of pedestrian facilities on the west side of the road. And this will include 4 different design alternatives, including one no-build option, as well as the selection of a preferred alternative based off of Snohomish County's recommendations and our engineering knowledge. So here's our project site again. 52nd Avenue is classified as a minor arterial road, which is characterized by a posted speed of 35 miles per hour and medium to high vehicle capacities. So here are our current conditions. Right outside of our project site is where the sidewalk ends pretty abruptly at the north and south end of our project site. So then this would leave just the west shoulder for both pedestrians and cyclists to travel through, along with oncoming traffic.
Some limitations we need to consider in our project includes the earthen hill along the Sunquist Family Nature Park, where this hill is only allowed to be excavated within right-of-way limits to create enough space to construct a pedestrian facility. Another constraint we need to consider is the culvert near Lunds Gulch Creek, which exists 20 feet below the existing shoulder, and this area must remain undisturbed as much as possible. The third constraint we need to consider is the earthen dam, located at the southern portion of the site, which exists part of the Lunds Gulch Regional Detention Pond, and this area must remain undisturbed as well. As for our project scope, we'll have to deliver a 30% design report to develop a pedestrian improvement plan with 4 design alternatives, which is a culmination of all of our tasks and deliverables we've been working on this past year. As for our basis of design, we utilize the Engineering Design and Development Standards, the Washington State Department of Transportation, and the American Association of State Highway and Transportation Officials to comply with all design standards for drainage, utilities, pedestrian facilities, and wall designs. Title VI applies to inform everyone within the community to accommodate the needs for the American with Disabilities Act, non-English speakers, and to provide environmental justice.
So this is a minor arterial cross-section as per the Snohomish County EDS manual. So this is a typical cross-section that we're going to be basing all of our designs off of. So if you look in the middle, there's a 12-foot turn lane followed by a 12-foot drive lane on either side. And then there'll also be a 5-foot bicycle facility for bicyclists. And then it'll be a 5-foot sidewalk separated by a 5-foot planter strip. These are the existing conditions here at 52nd Avenue West. So this will be a plan view. And then if you look to the right here in red, you'll see right here, you'll see the sidewalk. It currently exists on the east portion of the roadway. It'll continue from the south end, which is the Linwood city limits. And then it'll continue northbound until it gets to 164th Street Southwest. And then adjacent to it, you'll see that there's a bike lane. So this bike lane currently starts right after Lunds Gulch Earthen Dam. So currently bicyclists have to share the roadway with other vehicles until they get to this bicycle facility. And then up in the east section of the roadway north, you'll see the bicycle lane ends here just before the crossing. And then bicyclists have to continue onto the shoulder of the roadway until Linwood city limits. And then also you'll see up in the north end where the red is, that the sidewalk where abruptly ends that we mentioned earlier, and it continues back up down here at the bottom towards Lunge Gulch Creek. And then this will be the existing condition cross section of this roadway. So at the Earthen Hill section, you'll see there's a 0 to 9 foot taper, and then there'll be a 12-foot turn, drive lane on either side of that. And then on the east portion, we have the 5-foot bicycle facility, the 7-foot planter strip, and a 5-foot sidewalk. And then on the west portion, which is our main concern, would be that 5-foot shoulder. And then for the Lunge Gulch section, we have the 5-foot sidewalk along with the 11.5-foot drive lane on both sides, and then the 5-foot shoulder, which is going to be our main concern on the west side. So for alternative one, we're going to be proposing to add a shared roadway, which is highlighted in orange on the southeastern portion of the road. And then, so the way bicyclists coming from Linwood City from here, they could continue onto the shared roadway without sufficient space to share with vehicles. And then they'll continue on to the bicycle facility heading northbound. And then on the east portion of the roadway, you see in purple and red, there's a sidewalk and a bicycle facility that continues all the way down south. But as you can see, the sidewalk here, there's some highlighted in red and some highlighted in green. So the red sidewalk represents a permeable sidewalk. This allows water to infiltrate into the ground, reducing the runoff water. We did not include the permeable sidewalk at the Lunge Gulch Creek section, as that does not, we do not want water infiltrating down into the earthen dams structure. And also the roadway does constriction there as well. This is going to be the cross sections for our alternative one. So for the Earthen Hill section, we're going to be replacing the shoulder with a 5-foot sidewalk along with a 5-foot bicycle lane. This would cause the roadway to be extended by 5 feet. And then at the Lunge Gulch section, we'll be replacing that drive lane with a 14-foot share lane on the east portion. And then on the west portion, we'll be replacing the sidewalk, the shoulder with a bicycle lane and sidewalk. And then this will cause the roadway to be extended by 7 feet. As for our alternative two, it's very similar to alternative one, except the difference here is that we're going to be adding a bioretention planter strip here on the east portion of the roadway at the Earthen Hill section. So this dark green here represents that bioretention planter strip. And then you'll see that we also still have the sidewalk for the Earthen Hill section all the way to the Lunge Gulch Creek section, which leads to Beverly Hill Elementary School. And on the east side, we'll still have that shared roadway that leads to the bicycle facility. This is the alternative two cross section. So for Earthen Hill section, we'll be replacing that shoulder with the sidewalk, planter strip, and bicycle facility. And this will extend the roadway by 10 feet. For our Lunge Gulch section, we'll be replacing that 11.5-foot drive lane with a 14-foot share lane. And then we're replacing the shoulder with a sidewalk and bicycle lane. This will extend the roadway by another 7 feet for this alternative. For alternative three, it's very similar to alternative two, but except for we're going to be on the east portion of the roadway, we'll be adding this bicycle facility that starts at the Linwood city limits. So the way bicyclists, as soon as they enter to Snohomish County, they'll be able to enter a designated bicycle facility all the way heading northbound. And then on the east portion, we'll still have that bicycle facility. So a bicyclist could come from 164th Street all the way to Linwood City and to Beverly Hill Elementary School. And then also we would have that bioretention planter strip between the Earthen Hill and the bicycle facility, or between the sidewalk and the bicycle facility at the Earthen Hill section. And then the sidewalk will continue all the way to Beverly Hill Elementary School. And then this is the alternative three cross section. So for the Earthen Hill section, we'll be replacing the shoulder with a bicycle lane, planter strip, and sidewalk. And then at the Lunge Gulch, that would be extending the roadway by 10 feet there. And then the Lunge Gulch section, we'll be adding a 5-foot bicycle facility on the east section of the roadway. And then on the shoulder for the west side, we'll be replacing that with the sidewalk and bicycle lane. And then we'll extend the roadway by 10 feet as well. So for our fourth and final alternative, this is going to be our no build option. This is basically the project site will remain as is. However, though, this will not meet any of the requirements set forth by Snohomish County to add a pedestrian improvement plan for the west portion of the roadway.
Thank you, John. This is an existing roadway cross section at the Lunge Gulch Creek area. And in order to provide improvements to the west side, we will have to go over that existing slope that's there. So we propose adding a geogrid reinforced wall to mitigate the impacts on that culvert and the Lunds Gulch Creek that flows through that culvert. So that will require a partial excavation of the hill and then a construction of a geogrid reinforced wall with geogrid reinforcing in between the layers. And the improvements will be built on that geogrid reinforced wall, and it will be a 6-to-1 slope. And this is a photo of approximately how the wall will look like after it's constructed. This is the roadway cross-section at the Sundquist Family Nature Park area. And we also have a cut slope there that we propose adding a rockery wall there. And this will include excavating a portion of that hill and then building a 9-foot tall 6-to-1 slope rockery wall with an under drain, and then adding our improvements to that section. And this photo shows approximately how that wall will look like after it's constructed.
So our team created a decision matrix tool to select a preferred design alternative for a pedestrian improvement plan, which is based on 5 categories, and that includes environmental impacts, cost of improvements, pedestrian and bicycle facilities, and meeting standards from the county's minor arterial cross-section. And to analyze environmental impacts, we utilize the climate change tool to examine changes in temperature, water quality, flooding, and erosion impacts. And the climate model projects an increase in temperature, stream flow volume, sea level rise, and landslide hazards. And based on this table, design alternative 3 has the highest amount of new added hard surface areas where low impact development, best management practices will be implemented to minimize erosion impacts.
For the cost of improvement section, we utilize the Washington State Department of Transportation unit bid analysis, which basically looks at historical prices of construction items that WashDOT used in past projects. And with this cost analysis, we found that alternative 1 will cost $1,244,000. Alternative 2 will cost $1,326,000. Alternative 4 will cost $1,416,000. And alternative 4, which is our no build option, does not have any costs associated with it. For our pedestrian facilities, we looked at the number of pedestrian facilities added and also the separation from the roadway of those pedestrian facilities. For the bicycle facilities, we looked at the number of bicycle facilities added and also the separation from the traveling roadway of those facilities. For the meeting standards category, we just looked at the number of deviations from the standard minor arterial county cross-section that we looked at before. So with this, we developed a decision matrix. It's a lot to take in, but you can see alternative 3 comes out on top. This is our alternative with the sidewalk, the planter, and the 2 bicycle lanes. And it scored the highest because it has the most pedestrian facilities, the most bicycle facilities, and it meets the most standards. And although it does have a higher environmental impact, there's not much difference between the other 2 alternatives in terms of environmental impact. For alternative 4, which is our no build option, you can see it scored the lowest, and that's because it does not provide any additional pedestrian bicycle facilities, and it does not meet most of the county standards. And not only that, but this alternative does not meet our project scope, as it does not provide any improvements as intended by Snohomish County. So this is a plan view of our preferred alternative, which is number 3. And just to reiterate some of the advantages of this, we have the 2 bicycle lanes in purple, which will allow cyclists to travel both northbound and southbound. We have a continuous sidewalk that links 164th Street Southwest down to Linwood city limits, which would provide pedestrian access. And we also have a bioretention planter and also a permeable sidewalk, which is part of our low impact development practices. These are our references of design, if you can glance at them really quick. And thank you for listening. Any questions? Yes. Yeah, so we're aware of that option, but as of this moment, the county standards do not have that in that well, in their standards, the separation of both the bicyclists, the cyclists, and the pedestrians. So our main goal was to go off the Snohomish County standards. So that was our reason for providing the planter in between the bicycle lane and the sidewalk.
Yes, so for design alternative 3, it will consist of 3 catch basins along the gutter line of the bike lane, where the storm water runoff will infiltrate through the proposed catch basins and through the permeable sidewalk and the bioretention to increase infiltration, where the storm water runoff will flow through the under drain pipes and down through the existing catch basins and through the detention pond, and that leads to the culvert and through the creek. Sorry.
Yeah, so we have compiled a list of all of the existing utilities in the area. However, our project scope does not include finding the elevations for those utilities as of yet. So without the elevations, we can't really tell whether a conflict will occur or not. So that'll be in the 60% design plan.
I have room for about one more. Yeah. So as far as we're aware, and from the information we got from the county, that permeable sidewalk, it does tend to clog up. So it does require county maintenance technicians to go and remove that, the whatever debris or something that's clogging the permeable sidewalk. As of pertaining to like the walls, we're not aware of any upkeep of that. And just the standard, if there's a storm drain that's clogged, that will have to be cleaned out. But so far, those are the only 2 things that we're aware of in terms of upkeep.
Thank you, team. So that brings us to the end of the first of our 2 sessions. We'll meet back here in 15 minutes for our second set of 3 talks. For those of you who are interested, there are posters upstairs on the 2nd floor. So go up 2 flights of stairs and all of the teams have posters. So there will be team members at those posters right now, I believe, and then throughout the next session. And then all of the students in the department will be at their posters at the end of the next session. So I'll see you back here in 15 minutes. All right, it's about time to get going again. So everybody grab a seat. So our next presentation is by team 23.1. This was sponsored by the Black Farmers Collective, and I'll invite the team up to give the presentation.
Hello, everyone. I'm Juliana.
I'm Aiden.
I'm Michaela.
I'm Isaac.
And we are team CEE 23.1.
So going over a brief outline of our project, we're first going to go over project overview, a basis of design, a couple of our alternatives, our final design chosen, some final recommendations, and a brief Q&A at the end.
Taking a look at our project management structure, we have our 2 project sponsors from the Black Farmers Collective, Ray Williams and James King Jr. We have our project advisor, Brianna Salaya, our project coordinator, Dr. Wes Lauer, and the 4 of us that make up Team 23.1. So the Black Farmers Collective is a nonprofit organization who started Yes Farm in 2017. Yes Farm is an urban farm located in the Yesler Terrace neighborhood. And this farm provides an opportunity for the surrounding community members to have a green space to heal and learn with the land. Yes Farm also donates a large quantity of their produce to BIPOC communities.
So situating ourselves, here we have a satellite view of the First Hill neighborhood. You can see the star right there signifies where we currently are at Seattle University. And if you travel down south towards I-5, when you hit Yesler Terrace, you'll find Yes Farm. A slightly closer view now, you can see that directly to the south of the farm is I-5, and most of the operations are currently taking place at the north end of the farm, and then as you travel south, they're currently expanding the operations there. Now for a view of the farm itself, this is from the southern end of the farm looking towards the north. You can see in the background there, they have a greenhouse where they're currently growing plants and collecting rainwater. Additionally, they're also collecting rainwater at their tool shed, and the other side of the farm is where they're growing their crops. In terms of the existing conditions of the farm, they currently have an 1,100 gallon cistern at the very north end of the farm, which is getting the water from free twice weekly from Seattle Parks. However, this will change later this year to a paid connection from Seattle Public Utilities. Additionally, they're storing their rainwater collected from the greenhouse in a 1,500 gallon cistern and the rainwater collected from the tool shed in a 1,400 gallon cistern. They additionally have 6 2,500 gallon unused cisterns at the southern end of the farm. And their water that they have on site is used to hand water both the beds that are planted in by the community and controlled by Yes Farm. And that hand watering is very labor intensive and not very water efficient.
Okay, going over our project goals. So we characterize the existing conditions of Yes Farm, also calculating the water demand while maximizing the amount of rainwater that can be collected. Then we developed the water distribution system, also known as the irrigation system, thus reducing the amount of manual labor that's needed on the farm. For our basis of design, we use Seattle Public Utilities and the Uniform Plumbing Code. Seattle Public Utilities was used to help calculate the cost of SBU water that will be needed for the farm, also to help calculate the amount of rainwater that will be collected on Yes Farm, while the Uniform Plumbing Code was used to help develop our irrigation system.
A major factor that we had to figure out at the very beginning of the project was the topography of the site. So one of the first things we did was we went down there and conducted a GPS survey of the farm. And one of the results from that survey was this 10-to-1 view, as you can see, a profile view of the eastern end of the farm. And the main question that we first wanted to answer before proceeding with our design was whether we could hook up those 6 unused cisterns at the southern end of the farm and feed them with the rainwater collected via gravity. So as you can see, the northern cistern to the very left of the image and the greenhouse cistern are above in elevation of the southern cisterns, while the tool shed cistern is roughly equal in elevation. And taking that into account and accounting for friction head, we were able to determine that the southern cisterns could indeed be fed by gravity, which informed our design going forward.
So going over our 3 alternatives that we came up, our first alternative is to continue using the existing cisterns on site with the addition of SBU water. Our second alternative is to continue using the existing cisterns while also connecting them to the 6 unused cisterns on the southern end of the farm, and also using a pump to help direct the water to our irrigation system. And alternative 3 is to build off of our alternative 2 while also adding extra rainwater collection over the 6 unused cisterns on the southern end of the farm.
In order to analyze our 3 alternatives, we first needed to calculate an irrigation demand. We worked with the Black Farmers Collective to estimate our crop distribution on the site, and then conducted further research in order to find the crop needs as well as their average growing seasons. From there, we used precipitation data from the National Weather Service's CTAC rain gauge over the years of 1981 to 2010, and we took the monthly precipitation data, subtracted that from our crop water demand, and we ended up with the irrigation demands shown here. So this shows the water needed from irrigation throughout the year for the farm. And as you can see, we're not really needing any from the months of October through May, which makes sense as this is our rainy season here. And most of our, or all of our irrigation is needed from June through September, which is our driest season, as well as the primary growing season for most crops. We then evaluated each alternative's ability to meet this demand. To do so, we created a water balance for each of the alternatives, which looked at the water going in and out of each system. This allowed us to compare a couple of different things, first being the amount of water in storage in the system throughout the year. So this graph here shows each alternative's water in storage throughout the year. We have alternative 1 in dark green at the bottom. And you can see we have this 2,900 gallon storage capacity, which consists of the 2 cisterns at the greenhouse and the tool shed. And so we're seeing that our capacity is met very early on in the wet season in about October. So there is rainwater that's being collected beyond this. However, the farm is not able to currently use this due to the storage limit. For alternative 2 and 3, with the addition of the 6 southern cisterns, we increased our storage capacity to 19,000 gallons. However, we're still seeing that this capacity is met in about halfway through the wet season in January and February. So storage capacity is really our limiting factor in all 3 designs. However, we did see that by adding the additional 6 cisterns and increasing our storage, we were able to decrease our reliance on SPU water. So here we have the supplemental water needed from SPU. This is our irrigation demand that's not able to be met by our rainwater. So alternative 1 is again in the dark green here, and you can see that it follows about the same trend as our water or our irrigation demand. So from the months of June through September, we're really relying on that SPU water for the majority of irrigation. For alternatives 2 and 3, we're able to decrease this range to just the months of July through September. So we're able to decrease that reliance heavily, but again, the limited storage is our limiting factor for these designs.
So we also developed a cost estimate in order to better analyze our 3 alternatives. So here you can see a 30-year projection of our 3 alternative costs. On the bottom axis, you have that projected year, and along that side axis, you can see the total cost. So here you can also see that alternatives 1 and 3 are very similar in cost. However, this does not take into account the amount of time and manual labor that is spent on the farm with alternative 1. And alternative 2 is significantly cheaper in the long run. However, it also doesn't have that increased rainwater collection, which we were really seeking with this project. So we also used a decision matrix in order to better analyze our 3 alternatives. So after further discussion with our sponsors, advisor, and within our team, we were able to delegate which of those factors that you see on the left-hand side are the highest priority with our final design. So increased rainwater collection, along with future-proofing the farm for further expansion as they're looking to expand along the southern border, we saw that alternative 3 deemed to be the best design to move forward with.
With alternative 3 being chosen, we could see that there's an increase of over 500% of water storage on the farm, while also an increase of 38% of rainwater collected, while there's a decrease of 22% of SPU reliance on the farm.
Taking a deeper look at our final design, we have the SPU water connecting directly to our northernmost cistern. We are continuing to collect rainwater from the roofs of the greenhouse and the tool shed and storing that in their respective cisterns. We will be adding the additional structure above the 6 southern cisterns, which will increase our rainwater collection area, and all of that water will be directed into the 6 cisterns, which are also connected at the base. We will then have an underground conveyance pipe connecting all of the cisterns and directing water, towards the 6 southern cisterns. We will then have a pipe coming out of those cisterns, feeding into a pump, which will supply the water to our irrigation system at the center of the farm. And lastly, we will have an overflow pipe coming out of those 6 cisterns for any water that exceeds our capacity, and that will be directed directly to an existing detention pond on site.
So here now you can see a plan view of our proposed irrigation system. So these 3 boxes make up the main planting area on Yes Farm. And we plan to install around 900 feet of pipe, as Juliana mentioned, underground. And this will be coming from the 6 southern cisterns, and it'll travel through the pump and then distribute throughout the plots. And at each of those connections along that main line, there'll be a shutoff valve located for the farm's convenience. And throughout these plots, we will have our chosen irrigation method, which are wobblers. There'll be 10 of them to ensure adequate coverage of all the planting areas. And these diameters will be at around 28 feet. And you can see here a photo of what these look like. They'll be out of the ground at 1.5 feet tall. And these were the chosen type of irrigation method due to the fact that they provide larger water droplets, which decrease the amount of evaporation.
In terms of the impacts of our project, it will
It will positively impact the environment by helping to reduce runoff, which will help to reduce the risk of subsequent CSO or combined sewer overflow, which happens during high rain events when the sewage system is overwhelmed and sewage flows into water bodies such as the Puget Sound. So we want to reduce that as much as possible. We also help to conserve potable water as we're maximizing our use of rainwater for irrigation. Economically, we help to reduce the cost of water for the farm, which allows for funds to be directed towards new programs as well as other improvements on the site. And we also potentially increase their crop yield by allowing for more efficient water usage. Socially, our project will help to reduce the manual labor on the site needed for the upkeep of crops by both community members as well as farm workers, which will increase the accessibility of the farm, especially for those that may not be able to participate in those more labor-intensive tasks. We'll also be creating new opportunities for Yes Farm to educate the public on both rainwater harvesting practices as well as sustainability overall.
Now, with our design complete, there are a few considerations to keep in mind as this project potentially moves towards construction. First of all is the fact that while SP water is potable, collected rainwater is non-potable water, and that should be signified on site depending on where those things are stored. Additionally, the fact that Wobblers have a circular watering area, whereas Yes Farm currently plants in rows in rectangular beds, that geometry of planting might have to be changed to achieve more optimal efficiency. As well as that, because the farm is frequently open to the public, an increased security for the infrastructure that we add is optimal because we don't want anything to get damaged or stolen. As well as that, there are existing structures on site that will need repair, such as the greenhouse, which has a few rips and tears in it, so it doesn't have optimal rainwater collection. And finally, the biggest takeaway from this project is the fact that the limiting factor on site in order to achieve water independence is that storage, because even with the added storage that we're adding with our design, they still meet that about halfway through the rainy season. And so if they can add more storage in the future, they could seek to achieve more independence and reliance on rainwater. So with our design in mind and those recommendations, they can hopefully become a more welcoming and more environmentally sustainable place in the future.
Thank you. Any questions? So two answers to that. First off, we will be screening the water at the gutters when they're collected. So we'll have gutter screens for leaves and bugs and things like that, any physical contaminants. We will be citing that the water is not potable because it's technically not being treated. As far as electricity, do you want to take that one?
Yeah, as for electricity, the Yes Farm currently owns a gas-powered pump, which they want to use because they don't want to either look for another pump that someone wants to donate or purchase one, and instead use one that they already have. And the plan for that is to bring the pump in on site whenever they actually need to water the crops, because they don't want to leave infrastructure like that on site just in case it might get damaged or stolen. They already have the pump. So correct, yeah. That cost is included, but it's much less than actually buying a new pump.
Yeah, and also there's no electricity available on the site. So that's kind of the motivating factor of keeping the gas-powered pump, because as we know, electricity is more sustainable, but we wanted to make use of what they had on site existing.
So in terms of storage in the future, as they look to expand the farm, definitely there are other upgrades that we think they should take a look at. Because with their current rainwater collection, they would be getting roughly around an average of 80,000 gallons a year, whereas they only have about 20,000 gallons in storage. And increasing that in the future, they're expanding towards the southern end of the farm. where they could include more cisterns, the same ones that they have right now, those 2,500 gallon cisterns, and just simply connect them up to the system that we're already planning on building. And then hopefully they can increase their storage that way in the future. Oops.
Yeah, I learned a lot more about rainwater collection. I'm originally from Las Vegas, which does not receive any rainwater, so very different from Seattle. So when I took on this project and learned that there are ways to harvest your rainwater and use them both like residentially and at a farm perspective, it was just very interesting to see the options that are out there and the methods and process that it takes.
Also had a lot of fun like designing the irrigation system in general. It's just a fun thing to look at, just a bunch of water and trying to get it around to the farm using as little money as possible.
Yeah, I mean, also, I think one of the really fun things was just all the different ways all the different methods we had to discover new things during the project, like going down there and using a GPS survey, and then, you know, putting it in CAD and Civil 3D and learning all those different processes and those different software to make the design as best as we could. Learning all those things, some of them learning again, and then some of them learning for the first time, I think was a really fulfilling process.
Yeah, and I'd say one of the biggest things for our project was remembering the practical uses of it. And so remembering like the user side, because we can, you know, create all these fancy engineering designs and things, but if they're not practical for the people that will be using them, they're not really going to be effective. And so it was really interesting to get onto the farm and be seeing like how things work and how we can just improve what's existing there rather than, you know, creating some other design that's not really going to be usable for the people there. And also I learned a lot more about farming than I expected to from a senior design project. So that was a lot of fun.
Yes, so wobblers, as we stated, it is like the method that we chose due to the less amount of evaporation that's experienced. And the farm has used drip tape in the past, and that was a problem presented at the beginning of the year. However, a lot of rats kind of frequent the farm as well, and they would chew through the tape, which didn't really pose as a great method. So we were looking for a different method, and them being off the ground seemed to be the best.
All right, so before the next presentation, which is sponsored by Seattle City Light, we have a small award to give, and for that, I'll introduce Paul Smith.
Thank you, Wes. Good afternoon, everybody. I just want to say that it does take a lot of lobbying effort to actually run the most awarded senior design program in the nation, and that we take pride on that. And a lot of this is due to the commitment of the liaisons that make that possible. So not to take the spot away from the students, but it does mean a lot to us that we have liaisons here. So I want to this was already asked to, but I still like to ask another round of applause for our liaison for senior design. And now to single somebody out in that group of liaison, I want to say that in this group, there's actually a person who's done this the most, I think. It's been 16 projects he's been involved as a liaison, and his organization has actually sponsored 37 projects over the last 30 years. This person has been involved he said something between 10 and 15 years. We actually lost track, but it suffices to say that his commitment has been just remarkable. I think he has a lot to do with all this sponsorship that has happened over the years. So 16 are the ones that he's been involved, but he's just a champion for Seattle-U in all respects. He's actually a member of the advisory board for our undergrad program, also a member for the advisory board for the master's in structural engineering. So certainly a person that we appreciate a lot. He values the education in Snohomish. And so we wanted to just recognize that. So with no further ado, I just want to present the Outstanding Liaison Award for 2023 to Robert Cochran from Seattle City Light. So this is a total surprise, okay? So he didn't know.
And with that, I think we're ready for 23.3.
Hello, everyone. Today we'll be presenting a seismic evaluation of Seattle City Light's North Substation Control Building. I am Sami Almadani.
I'm Spencer Mashinsky.
Cami Miyagi.
And Madeline Phillips.
So the outline of our presentation today will be the project management structure, our project objectives, the background of the building, our project timeline, the building overview, our basis of design, our ASCE 41 seismic assessment and upgrade concepts, our cost analysis, and a brief Q&A session at the end. So our project management structure starts with our liaison, Robert Cochran from Seattle City Light, our project coordinator, Dr. Lauer, our faculty advisor, Dr. Smith, and we are the design team CE 23.3. So our project objectives is to complete a seismic analysis based off the ASCE standard 4117, as well as develop new mitigation ideas in order to bring the North Substation Control Building up to current code. The North Substation is located in the Green Lake neighborhood in North Seattle. It is a risk category 4 building, meaning it is an essential facility that needs to function continuously. It also provides power to University of Washington's Children's Hospital and the University Substation. The building was built in 1923 and later renovated in the 1950s. The north and south walls are made out of reinforced concrete, shown in blue, and the east and west walls are made out of unreinforced masonry, shown in red. These are the design standards we use for our project. First off is the ASCE standard 4117 for our seismic analysis, then the ASCE standard 722 and ACI 31819 for our mitigation developments. For our project timeline, during the fall quarter, we completed our preliminary calculations, which include the weight takeoffs, center of mass, and center of stiffness, as well as our ASCE 4117 Tier 1 checklists. During the winter quarter, we completed our mitigation developments, which include reevaluating our deficiencies, design mitigations, and evaluating the mitigations. During spring quarter, we completed our draft mitigation solutions, did our construction cost estimates, and finished our final report.
Next, we're going to take a little look at the building. So starting here with the plan view of the structure, we took this from Google Earth. It's roughly 95 feet wide by 72 feet, 8 inches long. And in blue are reinforced concrete walls, the north, south, and middle walls. And they're the lateral force resisting system for forces developed in the east-west direction. In red are unreinforced masonry walls, the east and west walls, and they're the lateral force resisting system for forces developed in the north-south direction. Next, we're going to take a look at some elevations, but I first want to highlight in the corner up here a plan view so that you know where we're talking about within the building. So starting with the south wall elevation, this is taken from our 1923 plans. It's one of our reinforced concrete walls and is typically 12 inches thick. These windows you see here were unfortunately removed in the 50s and replaced with unreinforced masonry block. Next, we're going to take a look at the middle wall. It's again a reinforced concrete wall. It's typically 8 inches thick. And here in yellow show some large openings within it, which drastically reduce the structural strength of it. And we had to take some considerations in our designs to account for that. And then finally, our last reinforced concrete wall is the north wall. The first 11 feet is 12 inches thick concrete, and it transitions to 8 inches thick above that. and it has largely remained unchanged since original construction. Next, we're going to take a look at the east wall elevation. This is one of our unreinforced masonry walls. It's made out of 8-inch unreinforced masonry block, and this east wall has a large door opening in the southern portion, and the west wall is identical to this without the door opening. Next, I'm going to take you inside the building by looking at a building section. Cutting straight down through the middle, we produce this. It's kind of split up into two halves, the northern half being our multi-story portion, and the southern half being our single-story portion. Starting in the north, we have the main floor. Then above that, we have the duct gallery, which houses some essential cables for this facility. Then the switchboard room, which houses the main controls for the substation operations. And then finally, office and storage space above that. Moving back down south is our single-story area, and it houses a large 60-ton crane resting on big concrete beams 32 feet in the air.
So this is our basis of design, starting with our seismic performance and hazard levels. These are for the damage or the level of damage, and this is based on the client, what the client will allow. So the damage increases from left to right as shown. And since we're an essential facility, we'll be designing according to immediate occupancy and life safety. The hazard level for immediate occupancy is a rare earthquake, and the hazard level for life safety is a very rare earthquake. This is our ASCE 722 pseudo-acceleration spectrum, and we're using this to find the spectral acceleration to find a value that can be used in an equation that resembles force equals mass times acceleration, otherwise known as Newton's second law. So this is the multi-period maximum considered earthquake for a life safety event. We calculated our period to be 0.2 seconds and found our spectral acceleration to be 1.58 G. We'll be using this value in the next slide to calculate our total base shear. This is our lateral force distribution, and in the bottom right shows our base shear value. And this is calculated using the 1.58 G from the previous slide, as well as the weight or the total weight of the building. On the left-hand side shows the story forces, which was calculated using the height and weight of each respective story in proportion to the height and weight of the total building. Reflecting on the base shear value, we see that it's very large and that it creates large inertial forces in the building, which has created some problems. This is our ASCE 4117 seismic assessment, and this is our assessment and mitigation process. First, we start off with the ASCE 4117 Tier 1 checklist, followed by the ASCE 4117 Tier 3, a detailed evaluation of our non-compliant items. We then did mitigation developments and did a reanalysis of the upgraded structure, followed by a cost estimate. From our ASCE 41, these are our assessment results, and these are our found deficiencies. First, starting off with the east and west wall, followed by the south wall for the vertical irregularities and out-of-plane failure, then followed by the roof for the skylight openings, the roof wall connection, and the diaphragm bending. To start off our mitigations, we have the east and west masonry wall. Unreinforced masonry is brittle and prone to out-of-plane failure and is not ideal during seismic design. So to mitigate this, we are going to remove the wall and cast the new shear wall on the north side of the building or install new brace frames.
Next, we're going to take a look at the south wall discontinuity. So I first want to show you guys the section cut of the south wall from the drawings, and we can compare that to a site photo we took in April. Now, this site photo, we're standing directly underneath the wall, as kind of shown here by the figure in the section, and we're looking up at the sky. So first, highlighting the south wall here in yellow, as you can see from the section, it doesn't extend all the way down to the foundation, which is an issue as the forces developed in there don't have a clear exit out of the building. Next, I want to notice this retaining wall, which does connect to the foundation, which is just a little more south of the south wall. However, there's no structural path between the south wall and the retaining wall. What you see here is a non-structural vent that just brings fresh air into the basement. So what we propose is looking at these crane beam columns, which connect both to the foundation as well as to the south shear wall. And we did some calculations to see if they could withstand the forces developed in the south wall. We found that they could not in their current form. So we decided to propose enlarging them to what you can see here. So in green is our existing column. Over here on the right, we have a section cut through the column. And you can see that we're proposing to enlarge it to be 2 feet 6 inches by 5 feet with a whole mess of rebar in there to increase the structural strength of it.
For the south wall infill removal, the highlighted areas in the south wall are currently made out of unreinforced masonry infill. It is a safety hazard considering it could break and fall down to the ground during an earthquake. To avoid such events, the team proposes to replace the unreinforced masonry infill with wood or steel studded walls.
Okay, so now for the roof upgrades. Here is a plan view of the roof, and highlighted in yellow is skylights, which are effectively just holes in that concrete roof slab. So when that earthquake hits the building, a shear force will travel horizontally through that roof slab in equal and opposite directions. And these holes mean that it can't be transferred at those points as it needs to. So we recommend installing horizontal bracing across those openings so that force can be transferred. Our second upgrade suggestion at the roof is at the roof to wall connection, specifically the roof trusses to the exterior walls. So when that earthquake hits, we expect these walls are at risk of out of plane failure, as that truss connection is not up to the current codes for our design earthquake. So we recommend installing an anchor at each truss to help strengthen that connection and mitigate that method of failure. Our third upgrade suggestion is again at the diaphragm. So when that earthquake again acts on the building, it encourages that concrete roof slab to bend, which is shown exaggerated here, and that creates tension in the concrete with the highest tension at those extremities. And concrete doesn't do very well under tension. So this is what that roof section looks like currently at the exterior walls. And to increase the tension capacity, we recommend installing cord reinforcing. So we have designed a channel that just is anchored to the roof to achieve this. So following the completion of our mitigation designs, we did a cost analysis that included unit costs, material quantities, as well as labor costs. This did not include the cost of any further design, which we have discussed with Seattle City Light would be necessary in order to implement our suggestions. And here's just a sample cost analysis for our largest mitigation suggestion, which is that east and west wall upgrade. These values were given to us by our liaison as relatively standard values that Seattle City Light uses that cover both the cost of the materials as well as some of that construction or labor costs. So at $500 per cubic yard of poured in place concrete, the concrete shear wall would come out to $150,000. And then for that brace frame option at $3 per pound of steel, the bracing would come out to $110,000. This doesn't include the hardware or connection costs, as that was out of the scope of our design. That's all we have for you today. Thank you very much. Any questions?
Yeah, so for the live load regarding the crane, we in our weight takeoffs, we gave an allowance towards it, and it doesn't get used very often. It's not yeah, I guess it's not a very used machinery, so I guess we didn't take super careful considerations while doing the calculations in regards to that crane. As far as some other assumptions, this may be a little technical, but we are assuming that we're treating the south wall as a rocking wall, which means it doesn't, let's see, how can I put this? It does. It kind of can break, we're allowing it to reach its moment capacity and break free of the diaphragm. And then that column that we're enlarging will take that moment capacity and be able to kind of write it, if that makes sense. And that was, I guess, the big assumption for that mitigation. Can you say that one more time?
We met a lot with our faculty advisor, Dr. Smith, and he kind of helped us with a lot of our mitigation solutions and calculations and guided us in the right directions. I hope I answered that correctly.
Yeah, so I didn't understand your question. My apologies. Thankfully, I mean, our faculty advisor, Dr. Smith, tremendously helped us with, especially when it comes to seismic calculations and knowledge. I mean, we've always had supplemental lectures at night, during Zoom, and he used to always give us, directions on how to do and what to do. So I appreciate Dr. Smith as well. So.
So in the original design, it was actually a temporary wall, and it was a wood wall which they replaced, we think, in the 50s renovation. So was never like structurally reliant. Like the floors, I guess, aren't attached to those walls the way up, so we can kind of remove it, I guess, without the whole building falling down, if that's your question.
Last question.
Was there a total for the final cost estimate? They follow all or some of the, like, do we have a selected portion of all together that you recommended?
Yeah, so we did do cost estimates for all of them. The total off the top of my head, I do not remember. And they were very rough. They don't include any permitting, very little demolition, which is a big issue with this one, is you can't just take a wrecking ball to it with all the facilities around it. So they're not in-depth cost analysis. It's really kind of construction cost for to build each mitigation rather.
Thank you.
So this is the final team, sponsored by Degenkolb and with collaboration with Korey.
Hello, everyone. We're team 23.2. I'm Lucas.
I'm Aaron.
I'm Juan.
And I'm Danny.
And today we'll be presenting you our capstone project of Camp Korey Fisher Lodge building improvements. Over the course of the academic year, we've been working closely with Camp Korey and Degenkolb engineers to complete the designs of both seismic and non-seismic building improvements at Camp Korey's requests. So today we'll be taking you through our project's management structure and objectives, a quick site overview of Camp Korey, as well as some as-built floor plans we developed of the Fisher Lodge building. Then we'll dive into our seismic assessment and retrofit, as well as our non-seismic building upgrades. Then we'll wrap up with our cost estimate, deliverables, and future work, as well as any questions you might have. Here's our project management structure. We'll start with the owners at Camp Korey. We've been working closely with Jay and Isaac, as well as our liaisons at Degenkolb engineers with Kale, Bianca, and Claire. Our faculty advisor is Dr. Kimaz, and our project coordinator is Dr. Lauer. Over the course of the year, we're also in need of some additional consulting work, from which we got the help from Nate and Russ of MG2 Architects and Sean of Light-Seismic Construction. The objectives of our project were to create an as-built floor plan set of the Fisher Lodge building, perform a seismic assessment and develop retrofit design concepts, as well as perform structural designs for accessibility upgrades, as well as a kitchen remodel.
Thank you, Lucas. Now let's look at the site overview. So Camp Korey is an adaptive year-round nonprofit camp for children and their family living with life-altering medical condition. And it is located about 60 miles north from Seattle. And the building we worked on in this project is called Fisher Lodge, located in the southeast corner of Camp Korey property. About this building, it was a student project from UW Architecture. It was built in 1968. And in 1994, the annex building was added to the north side of the lodge, which brings the total usable area up to 7,000 square feet. Right here, we have some exterior photo of the lodge. This is a 3-story wood frame building, and the main material used in its construction was Western cedar and Douglas fir. And during our project, we've been utilizing the Matterport model developed by our liaison Degenkolb using a 3D scan camera. And with this, we can visit the site virtually without being in person, and we can take some rough measurement. We start off with the south facade of the building with the main entrance. Moving towards to the west side of the building, we have the annex on the left side, along with the main floor on the right side. And continue to the north side of the building, have the better view of the annex. We have the north facade with the photo showing previously, and the residence floor right behind that. And continue to the east side of the building, we can see the residence floor having all the bunk beds right now, and the east entrance right there too. And about Fisher Lodge, currently it is used for storage space mostly, and gathering area and housing for the volunteers. And for the future plan, Camp Korey expressed their plan to provide more space for campers, also hosting more events. Now take a look further into the as-built floor plan, which we developed after a site visit in fall quarter. We have the main floor shown right here with the shear wall and hatch. It is about 81 feet in the north-south direction and 67 feet in the east-west direction. The shaded area showing the original building from 1968. And as I mentioned earlier, the annex building was added to the north side of the lodge, and the residence floor later on top of the main floor as a part of the original building. And for that floor plan, showing the next slide, we have the first and second floor have the same layout. The shear wall are also in hatch, and it's about 55 feet in north side direction and 46 feet in the east-west direction. With that, Danny can walk us through the seismic assessment.
So throughout this project, we used a variety of codes and standards. For our seismic assessment, we followed ASC 4117, the seismic assessment or evaluation and retrofit of existing buildings. We also got some design loads from ASC 716, and we made sure that our upgrades were in compliance with the International Existing Building Code, which takes precedence in Mount Vernon. For wood member capacities for analysis and design, we used the American Wood Council National Design Standards. This flowchart on the right shows the process we followed throughout the year to complete this project. We started in the fall using the Tier 1 checklists from ASC 41. These checklists allowed us to identify preliminary non-compliant items based on just a visual screening or quick calculations. These non-compliances we then evaluated further in Tier 2, which is a more in-depth analysis process. If we found them to still be deficient for the seismic loads in Tier 2, we created a retrofit design concept. At the same time as our Tier 2 process, we were doing structural design for non-seismic building alterations and also some architecture and drawing work. So more about the seismic analysis. This is a residential structure, so it's risk category 2. Our seismic hazard that we considered was the basic safety earthquake 2 for existing buildings, which is the seismic hazard with a 5% probability of exceedance in 50 years. Our structural performance objective at this seismic hazard was collapse prevention, which means people will be able to exit the building safely following a design level earthquake, but it may not be safe for future use. And the spectral response acceleration parameter, which we use to calculate the seismic forces experienced by the building during an earthquake, was 1.47 G, where G is acceleration due to gravity. This is our story force distribution based on the seismic forces that we calculated using that parameter. So the base shear that we applied was 266 kips based on the building's weight and the site classification. And then the story forces increase as we get higher above the ground level, except for at the roof where the weight is very low, so it decreases again.
So after our tier 1 checklist and some of the quick calculation, we found some deficiency and we move on to our tier 2. And one of that items is the roof core continuity. This is when the roof core span about more than 20 feet and it can create a deflection in the building diaphragm. So we identify these roof core on a roof framing plan shown in green. And with the calculated demand load on this cord, we choose the strap tie with the appropriate capacity to strengthen them using Simpson strong tie.
Another deficiency item that we identified was the wood sill bolts checklist item, upon which on our site visit, we did not observe any positive connections between the wood sills and the foundation of the building, which is critical for resisting lateral forces. So to design these anchors per ASCE 4117, we took each wall's respective shear capacity and used this information to model anchors in the Simpson Strong Tie Anchor Designer program and found that Titan HD screws of 3/4 inch diameter, 4 inches of depth, spaced at 3 feet on center were sufficient for resisting our loads.
Fisher Lodge also had multiple walls that were classified as narrow shear walls, which are any shear walls with an aspect ratio or just a height to width ratio greater than 2. During a seismic event, walls at this ratio may be very prone to overturning, as shown here, due to the lateral forces from the seismic event. And so to prevent this motion, a system similar to the right will be installed down on the ends of each wall, where there will be a hold down fastened to the end studs or end posts, and that will help connect the wood frame together. And then an epoxy anchor bolt will be passed through the sill bolt into the foundation to help tie the shear wall into the foundation.
Another deficient item we identified was the mezzanine overlooking the main living room. ASC 41 says that mezzanines either have to be independently braced against seismic loading or adequately connected to the main building's lateral force resisting system. By inspection, this mezzanine is not independently braced, and it is connected to the main building's lateral force resisting system at the shear wall shown in yellow. But because we did not perform intrusive observations, we couldn't determine the adequacy of that connection and assumed that we would have to completely redesign it. So the worst case seismic loading for the mezzanine is parallel to that shear wall, which will cause the mezzanine to both slide against the wall and rotate about the wall. So to resist that motion, we will have to have our connections create the forces shown in blue. It will hold the mezzanine into the wall and prevent the shear sliding, and the wall will have to be strong enough to not fail when the mezzanine pushes into it. So this section shows the anchorage that we designed. We have a hold down like Aaron mentioned, but oriented horizontally. This will prevent the mezzanine from pulling away from the wall. We'll have screws through the rim of the mezzanine into the studs of the shear wall, which will resist the shear forces. And then we also specified that the shear wall must have at least 3 studs at each end of the mezzanine to prevent it from buckling when the mezzanine pulls away or pushes into it.
So now we'll be moving on to some of the non-seismic building upgrades. So as mentioned prior, Camp Korey has interest in wanting to also improve the future use of Fisher Lodge. And to make that happen, it entails both improving the accessibility of the structure as well as also upgrading some of the current facilities. And this was done in close coordination with MG2. So currently we have the current kitchen here in a small multi-purpose room over in the annex side, and MG2 with us designed a new kitchen space in the wall on the other side of that wall that the current kitchen's attached to. And so here's kind of a layout of what it would turn into. We have a fridge, a stove, sink, dishwasher, some more expanded counter space, as well as also a pass-through through that wall. And then to help open up the space more, we're going to be removing a divider wall, as currently those 2 rooms are only used as storage. But unfortunately, this wall is load bearing, and so we'll have to also install a glulam beam and column, which we sized using the Wood Council National Design Standards. And then finally, also there's a small storage room down there in the bottom left, where we're going to remove the walls and doors and convert it into a small breakfast nook. And then to allow some natural light, we're just going to put in a window through that exterior wall. Additionally, also Camp Korey wants to open up the first residential floor to campers, as it's the only residential floor that's easily accessible from the exterior of the building. And to do that, they want a big focus on improving the bathroom accessibility. As we can see here through the walkway to that back wall, it's very narrow, which is not very conducive for those who may be in a wheelchair, as well as also the current shower stalls and the toilet stalls are not ADA compliant in size. And so MG2 has created a layout here for us where we'll be converting the 3 current toilet stalls into 2 ADA stalls. The walkway to the showers will be widened to allow for access by wheelchair. And then the 3 current shower stalls will be having their 2 divider walls removed, and a new curtain rail system will be added that will allow for the shower spaces to be modified based on who may be using it if they need more room. And finally, we had a big focus on the main entryway. So here, there's that raised platform there in the center, and just to the right of it, behind that wall, is actually the main doors. Unfortunately, as you can see, the only way to get down into this main room and then further back into the annex space is via the stairs right there in the middle, which unfortunately does limit accessibility. To accommodate for that, we will be installing a wheelchair lift right there next to the stairs. And so here we have a better view in plan, where again, the wheelchair lift will be attached next to the stairs. They're typically about 4 feet by 4 feet wide. We'll be opening up the handrail that's on the backside of that platform to be able to allow access onto the wheelchair lift. And then there on the right is just an example of how the wheelchair lift may look.
So next we'll take a look at our cost estimate, the deliverables we sent to Camp Korey and Degenkolb, and some future work to consider at Fisher Lodge. Lighted Construction helped us come up with this cost estimate based on their experience doing similar projects. All pricing is a rough order of magnitude based on the design concepts we sent and could change depending on the components used and who performs the project. They estimate it would be an 8-week duration with 6 full-time laborers. So labor would cost around $170,000. Equipment and materials would cost around $150,000. There would be $11,000 in supplier costs and $35,000 paid to subcontractors, bringing the total to just under $370,000.
So we have just submitted our final report to Camp Korey, and in that report, it included a series of plan sets we developed in AutoCAD. These plan sets were our as-built plans, our architectural renovation plans, our demo plans, as well as our structural plans with retrofits. Also, we'll be providing our ASCE 4117 Tier 1 checklists and Tier 1 and 2 calculations to support our suggested retrofits. Although our project is coming to an end, there's still some work left to be done. Isaac, the facilities manager at Camp Korey, had brought up an issue of general water damage due to the complex roof structure of Camp Korey, or the Fisher Lodge building over the year. This water damage is occurring in a skylight above the main lounge room due to seepage and in the main annex room due to clogging. We did not address this issue and it will require further investigation. Thank you for your time.
Yeah, I believe when we started the project, the 2018 IEBC was the most current. But I guess at this point, when they pursue this further, they will have to use the 2021.
I mean, there was a lot of aha moments as the other structural team, I wouldn't say an easier building, but a simpler structure. They had to do a bunch of these processes that we may not have had to do because it would have been almost impossible for us. So every time they had to do something, we were worried that we'd have to do it as well. And then our liaisons assured us that that was a little bit far out of our reach. So I guess that's for a moment.
Well, I guess the aha moment for most of us is after all the calculation is done and we can see, okay, overall, this is what we have done so far throughout the quarters, and putting all the drawings together, that's like the best feeling that we can say. Like this is reaching the end, I would say.
Yeah, I agree with Quinn. Definitely compiling those drawing sets was the biggest aha, because that's sort of the culmination of all of our work. Yeah, I guess kind of on the back of that is like the calculations we had to do were very dense and complex. And so when we finally got to a point where like we could actually start choosing some of our retrofit designs, it was very relieving, as like we realized like, okay, we actually got through probably like the hardest part of the project. Yeah, to be able to follow the code for like a ADA compliant ramp, it would have had to wrap, I don't know, like what, 40 feet or something like that. And that room just like, it's either cutting the whole room in half or it's gonna loop back and forth a good portion, where we didn't want to remove too much of the existing structure. As you saw, like there's like an inbuilt bench where we're putting next to, as well as also a fireplace that the ramp would have had to interfere with. Not quite. We didn't work super closely with them on that. But I believe this is a type of project that they're very used to doing. It's typical work for them. So
Nothing out of the ordinary. They said everything looked good.
I mean, we kind of live with this project for a whole year, and it's kind of inevitable to not looking at other buildings and saying like, well, that's a narrow street wall right there, you know? But well, we did point out when we do site visit and everything, we learn a lot, and definitely it's I guess it's getting to our blood now as an engineer. Yeah, a lot of evaluation, I would say.
well, we sort of, and the way I think ASC 41 operates is there has to be some credit given to how long old buildings have been standing. So if it's stayed up for so long without these things, you know, if it's never been tied to the foundation, more than likely we can give it another year. So the point of this project was to help Camp Korey fundraise for completing the project. So they'll use our work to approach sponsors or donors. And then they'll continue from there. I think hopefully it will be within the next few years, but there was no sort of prioritization of some retrofits over others. They were all around equal importance.
And that concludes the civil and environmental engineering presentations. There's, yes, thank you, everyone. So we'd like to ask all of the students who participated in the projects to come up now. We'll take a photo with the class. And I think it may take 2 or 3 minutes because we may need to grab a few students who are upstairs at the posters. Remember that there's a poster session on the 2nd floor. So it's 2 flights up immediately after this. So if you have additional questions, you can see the teams there. And thanks again to everyone for coming and for helping on the projects, for those of you who contributed.
And then finally, they don't have a good way of effectively measuring how engaged someone is with their organization. So for us to help them with that, it's actually not. You want to switch? Not switch. To help them with this problem, they gave us some of their data. So first, they gave us records of all past donations or gifts. They also gave us records of all people that have interacted with Camp Korey, such as donors. And then finally, they gave us the last year's records of volunteer activity to work with. So once we got that data, we moved on to cleaning. So there was a lot of steps in this process, so I won't go too in detail, but some things we did was identifying donors where they were missing donor IDs, and we filled those in. Also identified some duplicates where it was the same name, same information, so same donor, but multiple records, so we consolidated those. And then finally, we also calculated some key statistics for each donor, just to capture some information that we would later use in our donor engagement score calculation. So I'll go into the first part of our project, which was identifying donors with missing or with incorrect contact information. So the way we did this part of the project is we used SQL or SQL to pull donors that were marked as having invalid emails or invalid mailing addresses. And then once we had those results, we ordered it by their total giving amount so that when Camp Korey goes in to fix their records, they'll be able to prioritize those donors that were giving quite a bit. And here's just some information we captured about their donors. So as you can see, about 1/3 did not have an address listed, and about 92%, so quite a bit, did not have an email address listed. But good news, only about 2.2% had been marked as having an invalid address, and less than 1% were marked as having an invalid email address. So thankfully, there's not so much work to be done to fix this issue for them. I will now hand it over to Radhika to discuss the next part of our project.
Thank you, Leah. So our next task was to analyze giving timelines and donor segmentation. The recommendation that we had from Camp Korey was to use Power BI in order to build our dashboards. And we realized that a project like this can better be recognized by using a Power BI. So we took all of our clean data set, imported it in Power BI, created relationships between each of these tables, and here's our first dashboard. This dashboard talks about the gift amount trends that we received from individual donors. So Camp Korey has different donor types such as individual, corporate, government, foundation, and so on. We were interested in analyzing just the individual donors. We found that Camp Korey received a total of $4.47 million in donation in the last 3 years. A breakdown of that is shown in this line trend here. We observed a dip in the year 2021. So this dip could have been due to pandemic that quickly rose in the year 2022. Next, we also wanted to see what is the maximum amount that these donors were donating. And we found a single donor who donated about $300,000. It was a single donation. So these large donations make up a significant percentage of the entire amount that Camp Korey receives in a year. And it ranges anywhere between 7 to 17%. Next, this slide talks about the gift growth trends from individual donors again. We found that Camp Korey received about 4,753 gifts in the last 3 years. With this data, we calculated an average gift size and tracked it over the 3 years to see if the gift size was growing, staying the same, or decreasing. In this case, again, it decreased in 21, but that quickly rose in the year 2022. We also analyzed the quarterly trend of the gift counts that Camp Korey was receiving. And very evidently, we saw that Q3 is the time that Camp Korey receives most number of gifts. That trend, again, is consistent for all the 3 years. And also, Q3 months are July, August, and September, which is when Camp Korey organizes a lot of events and programs for their children. Also, this makes it very evident that the fundraising efforts are more enhanced around this quarter. Next. Now, in order to understand the giving trends better, we segmented the donors into 2 different categories, depending upon the amount that they gave each year. If the donor donated anywhere above $2,500 cumulatively in a year, they were categorized as large amount donors. And if they donated below that, they were categorized as small amount donors. Now, the graph here talks about donor proportion of these 2 categories. And consistently for 3 years, we saw that large amount donors constitute a really tiny portion between 6 to 10% of the entire donor database. The graph here talks about the donor amount proportion by each of these categories. And we saw that a major chunk of donation that comes to Camp Korey is given by the small proportion of large amount donors. Now, how consistently are these donors donating? Are they coming back year after year? We calculated a KPI called donor retention. And this graph talks about all the count of donors that Camp Korey has. We classified these donors into lost, new, and returning donors. Since our analysis started with 2020, we considered all of the donors who donated in this year as new donors. And we saw that the lost donors were relatively higher compared to the returning donors, bringing the retention to 35% in the year 2021 and 26.7% in the year 2022. Now, since the retention rate was so low, we wanted to be able to calculate an engagement score and see how engaged each of these donors are with Camp Korey. Now, Kartika here will talk about how we calculated an engagement score.
Thank you, Radhika. Since we could see that only 25 to 35% of donors in the past continue to contribute in the upcoming year. So there's a need to understand how involved the donors are with the organization. So we have come up with a metric called engagement score. Engagement score, it is the most valuable metric to measure the level of involvement and interaction of individual donors with Camp Korey's mission, program, and initiatives. We followed a 3-step process to calculate the engagement score. At first, we work with Camp Korey to understand the factors to identify how involved the donors are with the organization. Next, using those factors, we calculated the engagement score. Once the engagement score is calculated, we built a machine learning model to predict how engaged the donor will be in future with the organization. The measure and the model are really important and helpful for the organization to assess its impact, identify its area of strength, and develop its strategy to engage, to further engage and extend its reach. So let's gonna see like how we're gonna engage, how we calculated the engagement score. At first, we calculated the donation score, which is nothing but a metric to measure the level of financial support provided by the donor to the organization. Next is the volunteer score. It's another metric to measure the level of involvement and the impact of volunteers in supporting the Camp Korey's program and initiatives. Engagement score is then calculated by incorporating both these scores together by giving an equal weightage. So in donation score, we consider the variables like the total amount they donated and how frequently they contributed, and did they donate during any special events, and the recency of donation, and how consistently they've been donating in the last 2 years. For volunteer score, we consider like total hours they volunteered and how often they come up to volunteer. So these scores are calculated by assigning the weightage to the variables in it based on the organization's priority. For example, in donation score, the total amount donated has the highest weightage of 30% when compared to other variables. In volunteer score, the total hours volunteered has a 60% weightage when compared to the number of times they have volunteered. So combining these two scores, we get the engagement score, which falls in the range between 0 to 10. More the value, higher the engagement is. So I'm passing on to Aishwarya to talk more on predictive machine learning models.
The next part of presentation is predicting donation score. We have considered same variables which were discussed in the previous slide for predicting the donation score, but now we are using the data from 2018 and 2019 to predict the donation score for 2020 to 2022. Now let's look at the machine learning models that we have developed for making the predictions. We have developed two models for predicting donation score. The first is the random forest model, which is a simple tree-based model. Let's consider a decision tree which tries to predict whether a donor is highly engaged in donating or not. The first condition that it checks is if the total donated amount is greater than $150. So if an individual donates $100, which is less than $150, then the tree moves to the right branch and then checks for the next condition, that is, if the person has made any even donation. If it's no, then the tree assigns a donation score of 1.1. This is just for one tree. We have many such trees in random forest algorithm, and each tree makes its own predictions based on different conditions. And the final prediction is calculated by considering the predictions of all the trees and averaging them. The second model that was developed was using neural networks. It is a machine learning model which is inspired by the way human brain works. It consists of multiple layers. The first is the input layer through which the data is fed to the network. And in between, we have hidden layers which perform computation and learns the patterns in the data. And the last is the output layer, which gives the final prediction. A neural network uses neurons for transmitting the information, and these neurons have weights associated with them. And the neural network adjusts these weights while training to improve the prediction. So the model's performance was evaluated in terms of root mean square error. It is a measure that represents the average difference between the actual and the predicted values. For the random forest model, we got a root mean square error of 1.9, whereas for neural networks, it was 2.14. This tells us that random forest model has performed better than the neural networks since the difference between the actual and the predicted values is less. I'll pass it on to Leah for conclusion.
Thank you. Yes, in conclusion, we wanted to just discuss some things that we feel might benefit Camp Korey from our work today. So first, we believe by identifying those donors that had incorrect contact information, they will be able to go in, update those records, and hopefully be able to retain those people better. Additionally, our Power BI analyses, we believe, will help them to develop better, more efficient fundraising strategies. And then finally, our work on donor engagement scores will hopefully help them to not only identify who is engaging with this organization or who's not, but also predict someone's engagement into future years. We want to thank Seattle University and specifically our faculty mentor, Dr. Ariana Mendivle, for her support and feedback throughout this whole process. We want to thank Camp Korey and specifically Kathleen Banks, our liaison, for working with us this whole time and allowing us to work on this wonderful project with her. And then finally, thank you for being here and listening to us. We're now going to open it up to any questions.
Participants, asking how many layers can the neural network?
Yeah, we had 4 layers in neural networks. 4 dense layers and 2 dropout layers. I mean, with that, we got an accuracy of nearly 2.14, mean square error of 2.14.
That is a great question. I don't believe we looked into that, but that would definitely be an interesting thing to ask. I'm sure there was some overlap in that, you know, people that are sharing their information are maybe less likely to share their information, might not share both pieces, or maybe it's the opposite and people that are like, okay with just sharing one piece, like an email, wouldn't be comfortable sharing a mailing address.
Obviously, like neural networks is computationally expensive compared to random forest model.
All right, if there's no more questions, we will allow the next team to have some time to prepare. Thank you.
Hi everyone, myself Pooja and I have Nit, Fidan and Swati with me and we are team MSDS 23.2 and we have worked under Dr. Brian Fisher as our faculty advisor and Dr. Ariana Mendible as design coordinator. We have worked on predicting Costco's new membership behavior as which was sponsored by Costco's marketing analytics team. Well, who here has never been? Well, who here has never been to Costco or has never heard about it? Well, Costco provides one of the largest membership-based shopping experience. It has presence in almost 14 countries. It provides wide range of services such as gas, automobile, insurance, and travel. It provides high quality products at best price, and it offers multiple membership types such as executive, gold star, and business. Well, Costco wants to retain as much of its members as possible, especially the new members or the first year members. And we have helped them understanding different trends and relationship between the data sets. We have also created a retention model to predict whether a customer will renew or not and explored the options for acquisition model. This is the methodology we used. We start by understanding the data. We have explored the different data sets and relationships, and then prepared the data by cleaning and merging different data sets, which was then input to the machine learning models. And then we have chosen the best model out of it. Understanding the data. We received the data for customers who enrolled in year 2021. We have got the sales transaction for these customers in 2021 and 2022. We got the demographic information such as age, their household income, and the distance to warehouse. We also got the third-party data, which contained the interest level for different products. We then explored the different data sets. We started by exploring the sales transaction data. The plot on the left-hand side gives you the average sale for top 10 products, and the right-hand side is the average quantity for these products. The top 2 products are major appliances and gas, and you'll see that the sales for appliances is really high, but the quantity for these appliances is low, which is because the unit price of appliances is really high. And on the contrary, the unit price of gas is low, so the quantity for gas is high as compared to the sales. You'll also see that the green, indicating renewing customers, has more sales as compared for gas as compared to non-renewing customers for gas, which says that it is one of the important factors that can help us in predicting whether a customer will renew or not. Next, we explored the distance to warehouse. The plot on the left-hand side shows the average distance for renewing and non-renewing customers, and the plot on the right-hand side shows the trends of these customers. We can see that the average sales for non-renewing customers, so the average distance for non-renewing customers is slightly higher as compared to renewing customers, but the trend is almost same, indicating that distance to warehouse can actually help us in predicting, but we cannot rely completely just on this factor. We have cleaned this data. We have cleaned the data and merged different data sets so that it can be input into the machine learning model. Now, Nit will take you through the machine learning algorithm.
All right, thank you. So we tried using a couple different machine learning models, logistic regression, neural networks, and random forest classifiers. And all of these machine learning algorithms do pretty well at solving classification problems, which are problems where we're trying to predict a category, in our case, renewing or not renewing. So with all different types of machine learning algorithms, there's this trade-off between interpretability and predictive power. Logistic regression is pretty high in interpretability, which means that we can easily understand how the model is getting its predictions and explain them. On the other hand, we have neural networks and random forest classifiers. These are high in predictive power, which is just pure accuracy. So after training and tuning all of these different models for our data, for our problem, it turned out that logistic regression had pretty much the same accuracy as neural networks and random forest classifiers. So we decided to go with logistic regression models because these are more interpretable and these can probably help Costco out because of that. So here we're going to just go into logistic regression a little bit. Just as a note, all of the numbers you're about to see are not real numbers. They're just for demonstrative purposes. So here with logistic regression, we have different features. And what we're trying to do is split all of our data points, all of our observations, all of these are for one member. We're trying to split those into 2 categories, renew and not renew. And we do that by making this decision line that cuts through our data. And on one side of that decision line, we predict renew. And on the other side of the decision line, we predict not renew. So how do we get this decision line? We're using this log odds equation. So the logistic regression algorithm calculates these coefficients that we then multiply by the features, and we sum all those together. And this is a log odds equation. So what are odds? Odds is the probability of an event occurring divided by the probability of an event not occurring. In our case, it's probability of renew divided by the probability not renew. So with this equation, for example, we could get numbers like this. And by the way, we normalize our data before putting it into the machine learning algorithm, and that helps us with interpretation. So here we have just these fake numbers with a couple different features, gas sales, produce sales, and age. And one very simple indicator of how important a feature can be is just by looking at the absolute value of the coefficient. So the higher the absolute value of the coefficient, the more important that variable is in predicting renewal. So here it would be gas sales because that's the highest, the 1.25, and then the lowest is produce sales at 0.33. But we can even take this a step further. We can use the actual values of the coefficients. So if we want to focus on one variable, let's say gas sales first, we can leave all the other variables constant. And we're calculating here log odds. So we can take the inverse of log, which is using the exponential, and use that on just the coefficient. And this helps us compare a 1 unit change in our value of gas sales. So we can take the exponential of 1.25, that's 3.5. We can compare that to the value of 1. Going from 1 to 3.5 is a 250% increase. So the interpretation here we can make is the odds of renewal increases by 250% for every 1 unit increase in gas sales, which is $1 increase. Very powerful for Costco in deciding who could renew or who even to acquire. Also for negative coefficients, we can do the same thing, but comparing 1 to the exponential of a negative coefficient would actually be a decrease. Instead, we can flip that odds ratio over, and instead of interpreting the odds of renewal, we can do the odds of non-renewal. This time, odds of non-renewal increasing by 65% for every 1 year increase in age. So we thought that this level of interpretability could really help Costco in deciding what customers could renew and who to acquire in the future. So I'm going to pass it along to Fidan. She's going to go over the actual results that we got from our logistic regression models.
Yeah, so after slicing and dicing data, trying different features, combinations, and also trying to fit different models, we concluded that there is no one model that would be perfect in predicting renewal and non-renewal. And considering business needs of Costco marketing team, we decided to move on and giving them 2 models. First would be for low-cost channel, for example, emailing, and when you don't need to spend much money. Second one would be for high-cost channel, for example, print mailing when you have particular fixed budget. With low-cost model, our goal would be capture as much as non-renewing customers as possible. With our high-cost model, we'll try to increase our accuracy of predictions and we'll focus on more likely non-renewers. So with each model, we have some trade-offs. With model for low-cost marketing, we're capturing as much as non-renewing customers as possible. However, our accuracy lower than with our different model. So our initial results is first-year members end up non-renewing in 21%, and 79% of them end up renewing. With our low-cost model, we're able to predict 93% of them, and we're missing only 7% of them. However, when we're predicting renewal, we're predicting 80% of them as non-renewing, which ends up advertising to 83% of them at 24% accuracy. At first, it can be seen that accuracy is low. However, if you're able to target almost 93% of people who end up not renewing, it might be a good decision. So our second model is model for high-cost marketing channel. In this one, we're capturing less non-renewing customers. However, the customers that we're predicting will have higher accuracy of knowing that those customers will end up not renewing. So we're starting with our initial percentages, and we're able to predict 11% of them as not renewing, and we're missing 89% of them. However, great part of it is when we're predicting renewals, we're almost 100% have accuracy of predicting them. So it ends up advertising to 3.1% of members at almost 100% accuracy. Just to summarize those 2 models, with our low-cost marketing channel, we're capturing more people, 93%. With our high-cost marketing channel, we're capturing 11% of them. However, our accuracy is end up advertising to 83% of members with 24% accuracy. And for high cost marketing channel, we're advertising to 3.1% of members at almost 100% of accuracy. So Swati will go into details of our top predictors.
Thank you, Fidan. After running logistic regression model, we have narrowed down to a list of important features. We can see that age has a prominent role in our model, with indicating inverse relationship as it has negative coefficient. We can also see that group NN and frozen fruit quantity also has a negative coefficient value, again indicating inverse relationship. We can see that number of transaction, downgrade, upgrade status, and beer wine quantity have a positive coefficient value. And using these features, Costco can actually acquire customers to sign up their membership. Till now, we have seen the retention model and its important features. We have seen few issues in building acquisition model. So we only have a sales transaction data of members and retention model features. We cannot use these to build an acquisition model because we require an entire population data to capture non-member details. And also we cannot completely rely on poor third-party demographic data. In conclusion, we have successfully identified important features and developed a retention model that can help Costco's marketing team to identify and decide on which member to send and selective advertising. For first-year members, we have also discovered issues with an acquisition model. By looking at the first 3 months of the data of predicting renewal rate, we have seen that we have less predicting features. So to further on, we would like to experiment with more features using item level data to increase predicting rate. And by improving the reliability of third-party data and by gathering a desirable amount of population data, we can actually build an acquisition model in the future. Before closing, we would like to thank our Costco liaisons, Brian, Malav, and Michael, for providing us this opportunity to work on this wonderful project. And we would also like to thank our faculty advisor, Dr. Fisher, and design coordinator, Dr. Mendible, and our program director, Dr. Slaughter, for their extensive support and guidance throughout the project. We also would like to thank our project center for providing this opportunity. Thank you. And we are open for questions.
Yeah, so it's the people who sign up for the first time. And what Costco really wanted us to find was if we could predict renewal within the first 3 months. So we were using 1 month, 2 month, 3 month sales transaction data. Yeah. We did not. No, we did not look into that. So shelf life was not one of the columns in our data. So yeah, we didn't really think about that. That's a good idea though. But you are right. It looks like people who purchase frozen goods at Costco are less likely to renew. It's more of the fresh goods or like use a kind of specialty services. This is all over the US. Yeah, all first year members, all 3.8 million of them, something like that. Yeah.
Yeah.
You share with the audience just how much data you analyzed. I think there was a figure about the number of rows and columns that you shared with me. What's going on?
Yeah, we started with 400 million rows and we try to aggregate to have one column per each customer and ended up having 3.5 million rows.
Thank you.
Yeah.
So the Costco marketing analytics team, they don't deal with the actual marketing spend side of it. So we kind of just dealt with the sales transaction. I'm pretty sure if they were doing this together, it would probably be like an interdisciplinary project where they would like try to work with other teams to figure out the best solution. But we're just providing a possible, like the kind of the start to the research for them with this.
We didn't have data regarding what type of cards they are using. We had column for auto renewal using cards, and it wasn't in our top predictors. Yeah, but
Yeah,
that's
so
also
with your
interesting.
question, if all of the people going to Costco only can pay with Visa card, we wouldn't know, the ones that have a MasterCard as well. So yeah, it's just, it's bias in the data. Oh. Well, we got someone in the room here that's probably listened to you for that. Item level data.
Yeah, item level data.
It's very expensive. That's the problem. I don't even know if they collect that data because of how expensive it would be. So, but that we would think that would do a good job at prediction.
And also probably more reliable interest data. The data that was provided, it had almost like half of them missing. And the ones that we had when we were visualizing, it didn't make sense that people who are less interested, they were spending more. So maybe like third-party data, more reliable, would help us.
One person wants to know, you talked at the beginning about logistic regression or typical events, it's like no methods and forest. I don't know, did you try any of those other methods that are less interpretable? And so how was it accurate?
Yeah, we can go.
We
to that slide,
actually
think.
have one backup
Yeah,
slide
so we
for that.
trained all three of those models I mentioned. It's just that when we compared them, we could get similar results depending on what parameters we use. So because logistic regression is the most interpretable, we just went with that.
And time to train was also significantly different. So for example, for random forest, it would run for 40 minutes for 1 hour. With logistic regression, it might take like 15 minutes or 10 minutes.
Another question was this just based on 1 year's worth of data, or were you looking at results of a number of years?
So we had 2 years because if someone signs up in like late 2021, we need their sales transaction in 2022 to get the full year. But anyways, we were looking at 1 to 3 month data. But yeah, that's why our data was so much, because we had 2 full years.
And also important note that having like 3 months data did not add too much accuracy in contrast to having just 1 month's data.
One last question. Did you have data on which customers added up to the price of that?
Oh, we had city card data. It is like credit card that Costco provides. We use that predictor as well, but it wasn't in our top predictors by coefficients.
Okay, last we have our team from DeSimone Consulting Engineers. Let's give them a warm welcome.
Thank you. Good afternoon, one and all. We are Ram, Prateek, and Lee, representing Data Science Team 23.3. Today, we are excited to present our capstone project titled, A Data Curation System and Predictive Model for Unconfined Concrete Strength. In this presentation, we'll be briefing you about our esteemed sponsor, some of the challenges they are facing regarding the data, the solution we have designed to overcome these challenges, and finally, the significant benefits they get out of our project. We are grateful to have DeSimone Consulting Engineering, in short DCE, as a sponsor for our project. DCE was founded in 1969 and is a leading firm in structural engineering, facade consulting, and forensic services. They are highly recognized for their expertise in the field of concrete engineering. To date, DC has designed over 10,000 projects in 44 states and 54 countries. DC is consistently listed in Engineering New Record's top 500 design firms for the highly efficient and innovative designs. These are some of the remarkable buildings designed by DC. To ensure the sturdiness and longevity of these huge concrete structures, concrete strength is considered as one of the most important metrics. Now, let's discuss what is concrete strength and how it is determined in the construction industry. In the first image, we can observe a construction site where a truck comes in and delivers huge wet concrete mixer. From this lot, few samples are collected, molded in cylindrical shapes, and compression tests are conducted to determine the load at which the material breaks. As you can see in the video, the force is applied along only one axial direction, which means the specimen is not confined by any kind of pressure in other directions. Hence, this is called unconfined concrete strength. This is an important parameter to study, as this ensures the safety of a building and helps engineers to design safe structures. Some of the main challenges faced by DCE are, for any given project, the unconfined concrete tests are conducted by many independent testing agencies, producing a large volume of over 1,000 test data files. And these data files are currently presented to DC in a typical PDF formats. And these files are currently stored in DCE's network shared drive, making it difficult for engineers to store, retrieve, and analyze the data. Hence, there is a great need to establish an efficient system that helps them in analyzing and visualizing the data to study more insights about the concrete strength. Finally, there is also a pressing need to predict the unconfined concrete strength of a material. This helps engineers to predict accurate mix designs at a given temperature range and geographical location. This is one of the sample PDF reports received by DCE. This contains unconfined compression test results along with various other variables affecting it, as highlighted in the image, like site and concrete temperature, size of the specimen, date at which the specimen is tested, the required load the specimen should be, and the tested length. Now, Prateek will be explaining in detail about the solution we have designed to overcome these challenges. Over to you, Prateek.
Thank you, Ram. PDF reports are a common way to look at the data, but it can be most difficult to extract data from. It is because PDF reports are unstructured, as you can see on the screen. It doesn't have a consistent way to organize the data. To address such challenges faced by DCE, we divided our solution into two parts. On the top is the data curation system, on the bottom is the predictive system. Let me walk you through how data curation system works. Let's imagine you're an engineer at DCE working on a new site and have just received the reports from your partner lab for the site. Now you open up an Excel file, put the location of those reports along with the other information like project number, longitude, and latitude. Once that file is saved, our data scraper written in Python will extract all the important information and export it into a clean Excel file. This Excel file is defined in certain schema, which has all the primary keys and secondary keys. And it's ready to be ingested into any relational database or any analytics tool you might want to use. Next, our predictive system. It has two components, predictive model and a presentation platform. When we have the clean data from data curation system, our predictive model will be able to predict unconfined concrete strength for 7th, 28th, and 56th type. After that, a presentation platform built on Python will be able to visualize the results and also provide more information on the factors affecting concrete strength. Let's learn about the predictive model. We use artificial neural network to predict concrete strength. Artificial neural network is inspired by human brain. It is made up of layers of interconnected neurons. The first layer takes the input data, the last layer produces the output. In our case, that's unconfined concrete strength. The intermediate layers are known as the hidden layers, where the computation on data is performed as it passes through the network. Each neuron has a weight attached to it, which decides how important that is. When we train the neural network, the weights are updated to give better prediction. And this process is called backpropagation, and it starts all the way from the output layer, compute back to the input layer. Let me explain how this works. Let's imagine you want to climb the mountain. You start at the bottom following a trail. The trail here is a weight in the neural network. Your goal is to reach the top of the mountain, which is like making the correct predictions. As you start climbing, you might take some wrong turns, make some mistakes, but as you keep climbing, you get better at finding the trails and finally reach the top of the mountain. Backpropagation works in the similar fashion. It updates the weight and gives you a better prediction. It starts at the output layer, back to the input layer, calculates the error at each layer, then updates the weight and reduces the overall error. Let's look at a model performance. After trying numerous architecture of neural network, our best model had 11 input parameters, 4 hidden layers. The first layer had 300 neurons, second had 200, third had 100, and the last had 50 neurons. It gave us the test RMSE of 991, meaning the average error between the network's output and the expected output was 991 PSI. This is not a perfect model, but the best we could come up so far with the given data set. Let's look at the results that this model gave us. The significance plot shows us the importance of the input variables in predicting the concrete strength. And to not our surprise, the specimen required strength and the days it was tested came up with the most important, followed by its temperature. Now, this information allowed us to explore the relationship between these variables further, which will be explained by Lee.
Yeah, thank you, Pratik. So after we look at this plot, we decide to visualize and study the top 3 most influential variable, which are the required strength, the specimen age, and the batch temperature. So before we dive into that, I want to introduce these variables a little bit more. So the measured strength is the response variable of our project, and each specimen has their own required strength that they need to reach. The specimen age refers to the number of days the specimens are being cured before being tested. And the batch temperature is the temperature of the specimens themselves. So now let's look at our first plot. So over here, we study the relationship between our response variable, which is the measured strength, and the top 2 most influential variables, which are the required strength and the specimen age. So because the 7th, 28th, and 56th days are the standard days to test these specimens, and therefore they have the most data points there, we want to visualize the required strength versus the measured strength on these 3 days particularly. Over here, we have linear regression lines represent the trend. We also have blue ticks, which are the mean with each required strength. And the bars indicate the 1 standard deviation from the mean. So over here, we can see that only specimens with some specimens with very low required strength can reach their required strength on the 7th day. And then we can expect most of them to reach their required strength on the 28th day, except for specimens with required strength of 12,000 PSI. And after that, the specimens continue to cure and attain higher measured strength, and we can expect all of them to reach their required strength on the 56th day. So next, we want to provide an overall picture of how the specimens are cured over time. And here we introduce a new metric, the measured strength to required strength ratio. We plot this ratio versus the specimen age grouped by different range of required strength. And over here, we have logarithmic regression line instead of the linear regression line because that is the standard relationship between these 2 features. So over here, we can see that the specimens with required strength lower than or equals to 10,000 PSI behave roughly the same, which are shown in the first 3 plots, that we can expect them to reach their required strength on the 28 days there. And but that is not the case for the specimens with request strengths higher than 10,000 psi, and they need at least 56 days to meet their request strengths. And we also learned that there's a requirement about this ratio, measures strength to request strength ratio, to reach 1.3 in the construction industry. And our plot definitely suggests that the concrete need to be cured for longer if that requirement need to be met. So next, we bring our third most influential variable, which is the batch temperature. And we can see here, the batch temperature and the ratio tend to have a positive relationship in the first 14 days, shown in the first plot, except for the specimens with request strengths higher than 10,000 psi. And after that, they tend to have a negative relationship, except for the specimens with request strengths from 5 to 7,000 psi. This could provide some valuable information for the batch temperature manipulation in the curing system in order to achieve higher measure strength within the same number of days. However, we learned that the batch temperature is currently manipulated by adding hot water or ice, and both of them could potentially have a negative influence to the measure strength. And because of the missing data of water added, we cannot study the relationship between the batch temperature, water added, and measure strength in our project. But we would strongly recommend to collect this information, water added, so that further study can discover this relationship and provide some suggestions for a better curing system. So in conclusion, our project have addressed disease data management challenges by scraping the required data and establishing a data schema while minimizing the redundancies. We also established a narrow network model to predict the variable, the concrete strength, while identifying the key features. And from there, we visualized these variables while providing some valuable insights for our sponsor. So in general, our project would help our sponsor to save some time, budget, and labor, resulting in a positive impact. So that is all about our project, but lastly, we want to give our sincere gratitude to our sponsors, Dr. Jeff Dragovich and Matthew Comments from DCE, and our advisor, Dr. Ariana Mandibule, and also the Project Center of the College of Science and Engineering for their unwavering help, support, and guidance. Thank you. And also thank you all for listening, and we are now open to questions.
We only had data for 2 sites. We expect to have more data and then train it. Then it could be like production ready, just a prototype. I mean, right now we have, like, we're close to 991 PSI range. I mean, if that helps.
Sure. There are quite a few models, but the kind of data we have, we are left with only artificial neural network, because the most of the data we have are missing, because as we have already discussed, we are given data in PDF formats. So obviously the data is entered manually at the different testing laboratories. So that's the reason there is huge chances for data